Good evening, all the participants.
Good evening, ma'am. Good evening.
Good evening.
All the participants are joining. We will wait for more 5 minutes to join the participants, and then we will start.
कुछ बना
Hello, can you hear me?
Yes, I can hear you. You are audible.
Excellent, thank
Okay, we
you.
will start with the session. Good evening and happy Makar Sankranti to all the participants. Uh, as we know that I have already shared on the group that there is a slight change in the session. The rise of foundation models, GPT, PERT, and LLAMA. This session will be conducted instead of the Amol Patil sir's session. Today's expert, Mr. Deepak Patil and Mr. Ganesh Gungarde is going to take over the session. Before we start with the session, I want to give some instruction to all the participants that please put off your videos. Again, we are sharing the feedback and attendance link in the chat box only for today so that we can count the participants in the attendance. The link will not be shared on the WhatsApp group. You have to, the 5 minutes will be given to the feedback and attendance after the end of the session. You can have 5 minutes to mark your attendance. Now, moving towards the session, I will introduce our eminent speakers for today. Mr. Deepak Patil, he is a program manager from Houston, Texas, USA. He is an IT program manager with 20 plus years of experience delivering large scale enterprise programs, specializing in AI driven and data science enabled solutions. He is a proven leader in managing end-to-end project life cycles, digital transformations, and managed services with a strong focus on data-centric decision making. His core skills are AI and data science program management, data-driven digital transformation, analytics and insights delivery, enterprise data platforms and governance, stakeholder and customer management, agile and hybrid delivery models. He is coordinated cross-functional teams of data engineers, data scientists, architects, and business stakeholders. His key strengths are strategic leadership for AI and analytics programs, strong customer and stakeholder engagement, proven experience in transition and transformation projects. Our second eminent speaker is Mr. Ganesh Gungarde. He is a program manager. He is a VP, Northern East, Pune. His area of specialization are artificial intelligence and data science, AI-enabled digital transformation, enterprise and cloud security, program and project management. His professional experience is of 15 plus years in the IT industry with extensive exposure to AI-driven programs, data analytics, and enterprise digital transformation projects. Mr. Ganesh Dungarde is an experienced IT professional and program manager. Uh, His professional journey spans over 15 years, during which he has managed complex projects integrating AI, data science, automation, and information security. Now I hand over the session to the Mr. Deepak Patil and Mr. Ganesh, sir.
Excellent. Can you hear me?
Yes, you are audible.
Right. Okay. So let's give a couple more minutes for Deepak to join. Okay. But
Yes.
it's good to be part of this forum. Okay. By the way, hi, I'm Ganesh. As Deepali ma'am already explained or provided the insight or the intro about me. Okay, I was just listening to that intro about myself. Okay, it's been a while now. Okay, so thank you, ma'am. And I'm really glad to be part of this forum. Okay, just to give background, like I'm currently holding the security architecture space. That's what I'm currently leading with the Chicago-based bank. Where exactly I'm currently rolled into. In addition, there are different projects related to AI that we conduct reviews on. We opine on it, right? So that is something that I have a background about with 20 plus years of experience in security architect space. So that's where I am coming from. We'll give couple more minutes for Deepak to join. Okay. Um, so what we also can do is, right, if you have any questions as such, right, related to this particular session, okay, feel free to ping it on the chat, right? What we'll do is we'll collaborate and see what are those these areas of focus that you have, where we can take a look at it, and we'll come back to you meanwhile. Okay, so that's essentially what I would suggest, because we have a lot of people out here in this particular session. So handling requests or queries from everyone would not be a suitable one or feasible one. So what I would say is, right, I would request you to jot down your questions, put it onto the chat, right, and we'll take a look at it and come back to you about it. Okay. So Deepali ma'am, how we take these queries as such? Like, do we take their email IDs and question where we'll reach
You
out to
can,
them, or how is it?
yes, Ganesh, you can put your email ID there in the chat box so
Okay.
that the people can reach out to you. One more thing I want to that
Yeah.
you can you share your PPTs, or we will start sharing the PPTs so that it's
Yeah,
easy
yeah,
to
yeah.
do start with the session.
Right. Hold on. Give me 1 minute. Huh?
Ganesh sir, are you there? Are you sharing your PPTs?
Yeah, just give me 1 minute. I'm just, there is some glitch. Give me 1 minute.
Yes, sure.
Hello, am I audible?
Yes. Yes,
Okay.
Deepak sir.
Yeah, you are.
Welcome, Deepak sir.
Hey, thank you. Give me a
We
minute.
have,
I just joined using my phone. Let me try if I can join using my laptop.
yes.
Excellent.
One thing I want to mention is that uh, Deepak sir is having some medical problem with the throat infection. So he's trying to give more focus on the whatever the topic we have along with the Ganesh sir. So be patient to hear the session. Thank you. Thank you all participants. Ganesh sir, meanwhile, you can share your PPTs.
Yeah, 1 minute. Okay, right. Okay, I am having some issue while sharing it. Give me 1 minute.
You can share these PPTs with me. I will try to share it from my side
Okay.
if you are facing the problem.
Yeah. Okay, sure. Okay, can you see the screen?
Yes,
Okay, excellent.
it's visible.
Right. Okay, great. Deepak, you there? You back?
Yeah, I'm back here. Okay,
Excellent.
so let's get it started. Sorry, my throat is not well, so I may have to stop a little. Okay, so while creating this content, I kept the approach to make all of you knowing about what's happening in the current environment, how the new way of working that has been imposed to the IT sector, and how it is being implemented across. So this all the contents I created to make some AI related fundamentals to known to all of you. I'll cover up most of the things. If you have any questions, maybe once I done with my um, presentation, you guys can raise it. Okay.
So
So
Deepak,
starting with
quickly.
the introduction.
So
Yeah.
Deepak, quickly, what we did is right. There are more than 300 participants on this forum. So what I said
Yeah.
is either they can put the queries on the chat, or I have already also shared an email ID where they can send the queries which we can collect, collaborate and just respond back onto it if that is okay. Because it will be very
Yes.
hard for us to address all the queries out here.
Yeah. Yeah. Sure. Sure.
Okay.
Thank you.
Yeah. Okay.
Yeah, that's
Excellent. Thank
sure.
you. Yeah.
Okay. So I'll quickly start with the introduction. So hi all. My name is Deepak Patil. I'm into the IT organization from last 25 years. I've been handling multiple roles. I started my career as a administrator, IT administrator, developer, hardware engineer, and moved on my journey. And today, I'm a account manager or a program manager, handling multiple customers for an one of the Indian IT organization called Wipro. So I've been associated in Wipro from last 20 years. And currently I'm working from US location. The city is Houston. It's part of Texas state, and predominantly I work with the oil and gas customers. And for the last 10 to 12 years, my expertise is into executing the new programs, touching or utilizing the cutting edge technologies, making the best experiences in front of our customers, and understanding their needs, their problems, and helping them out with the solution. So that has been a key activities I've been doing all these years. I believe the contents and the experience I'm bringing out to you guys will give some new knowledge, or give some addition to your existing knowledge, and it will be helpful. Okay, so thank you for giving me this opportunity to share my experience in front of you. And thank you for Ganesh, who is my colleague, who is my friend. um, and he will be covering up whenever I'm stopping. So please bear with this hesitance. Thank you. So, getting started with the AI, I would like to make a little, friendly conversation. So, guys, any of you, if you can unmute and tell me what is your understanding about AI?
I know it's a very, sought after topic by, I must say. Everybody's talking about AI and all that, right? But then the
Right.
question is, do we really know what AI is? Any reflections? I know most of you are already involved in various, content creation, or specific subjects as such and all that. But then, given the collaborative session that we are currently having, so anybody who would like to talk state briefly in a one or two sentence itself, right? What do you think as per you AI is?
Recording in progress.
Sorry, somebody
Good
was
evening,
speaking.
sir.
Yeah,
Good
hi.
evening, myself, Dr. Rajesh.
Hi,
Uh,
Rajesh.
as per my understanding, artificial intelligence is somewhat making the human thinking in artificial way to achieve or to reduce the manual works of human, and even to act the machines. So everything will be taken care by the machines in future. Already we are crossed AI in many factors, but still, to reduce, to make the convenience for the human era, AI is supporting well in case of many things. If you take LLMs nowadays, we are trying to Google it, we are always go to ChatGPT or Perplexity or whatever, Cloud or whatever. So it makes human works reduce. It reduces the human work, and it will give more advancements in case of technology and communication, travel, etc. So it simplifies the human thinking also. So that is what I can say.
Okay, fair enough. Like, so if I can summarize Deepak for Rajesh, right? A kind of a human replica, which is basically used to, solve the problem that humans are facing currently and give it in more efficient and scalable way of doing it, right? Rajesh, correct me if, the summary is something that you would like to rectify. Yeah.
Yeah,
Okay,
fair enough. It's well understood.
excellent,
So
excellent. Anybody
this is
else? I saw a couple more people like, talking about it, but then
Basically,
no
it
worries.
is mimic the human behavior, although the current era is far ahead from this just mimicking the things, because we are in the era of the fourth generation of the AI, and we are reaching up to the like generative, where the number of things can be generated by the emotional quotient also with the AI, right?
right. Moving towards the AGI, if that is what you are talking about, right?
Mm. Oh,
Super
yeah,
super intelligence,
good.
general intelligence. Yeah. Go ahead.
Good. Let me give you, a little brief about the AI and AI journey. So maybe Ganesh, can you go to the next slide? Okay. So let's talk about the previous slide. Okay. So let's start talking more about the evolution of generative AI. So the AI journey until today, it has been like first in 1956, the concept of AI has been brought up. And when the AI concept initially brought up by people and they started looking at it, their first intent was to make an intelligence which can take up the activities from human. And the reason why they look it into the artificial intelligence is because they always wanted to look how we can reduce the manual errors, and we need something which can be trusted, which can be errorless, which can be flawless. So that is where the concept of AI has been first put, sometimes in 1950s, 56, sometime back. And from there, they started evolving. Okay, so first it came to AI. On top of that, then the new concepts came, like a machine learning, where on top of AI, they started looking at, okay, now in artificial intelligence, we know what are the thoughts that we are looking at, what are the things that human-related tasks that we wanted a machine to do. But then to do it more efficiently, I think somebody,
1 minute.
go on?
Yeah, if you're not talking, please go on mute. Sorry,
Jyoti ma'am, Jyoti.
Dipali ma'am, can we put people on mute? Like, is there any way?
Yes, yes.
Thank you.
Okay, cool.
Okay, so when artificial intelligence first came into picture, that time everybody thought about putting all the ideas together. That what are the different activities or the tasks that we want to handle intelligently, right? So that is what came into initial things. But to perform that more efficiently, they built a new model called machine learning. So machine learning, again, it talks about all data, coming up with more data points, understanding the reality. Sometimes what happens is um, uh, something comes in your mind. So earlier we used to call as experts. So experts used to come with their own experiences, and their experiences used to help in certain ways. But those experiences were not put into the system to follow a certain workflows or certain steps. So by understanding this machine learning that implemented to collect the data together and do the analysis on existing data. So AI gives you thoughts, machine learning gives you the analysis on the data points that are useful for your thoughts. And that is how the machine learning started implemented specifically into predictive analysis or any other type of analysis to get that. Further on, as the usage increased, they got into the deep learning. Now, the deep learning that has the further evolution happened where they discriminated or they distinguished the machine learning data into different types, categorized, and utilized more specific ways or specifically, right? So that is how the deep learning came in. And today, we all are talking about generative AI. Now, generative AI itself is a self-explanatory, which generates the AI. That is a generative AI. Means AI is used to, we started a journey to make our work smart intelligently. And now generative AIs are responding to AI. So they are generating the responses to our original ideas and they are becoming more intelligent. So that is how the all journey that we have. Now, each model or each section, I would like to take it in a little bit. So Ganesh, can you go to the next slide? Yeah. Okay, so AI, as I said, when AI concept came, initially we thought of, we need an intelligent system which is capable of performing human-related tasks. So that was the simple idea that originally got. Go to the next slide. Yeah. Now, when we talk about the machine learning, so machine learning was or is a subfield of AI, and that helps to make more on the predictions, forecasting, reactive analysis, or some more. Like as I said, machine learning typically talks about more and more data, more and more type of data, volume of data, or analyzed data, filtered data, all type of data. It works on that, and it gives you the analysis on that. Next. Now, a really interesting thing is deep learning. Why this deep learning was invented? So it is again a subfield of machine learning, but that focuses particularly on development and implementation of artificial neural networks. Now, what is artificial neural networks? Anybody has any knowledge about artificial neural networks? Okay, so artificial neural network
replicates the human brain, sir. Human brain, how the neurons present in the human brain, artificial neural networks works.
Yes. So here the term artificial neural network comes like understanding human language. Okay. So the deep learning section, the work happened more on like how a machine can understand humans' language. Until now, like until machine learning, it was straightforward, like putting at the ideas, putting it into the, getting it into the data. Yeah, and then in deep learning, it was typically to understand what a human wanted to do. So because that was the key challenges in using the AI um, that were discovered because every time if you want to make any output from any of the system, we need to convert the entire things into the program or the command line, and then the system used to understand and used to interact or give the output back. But in deep learning, they focus more on artificial neural networks where it can understand the human language using text, using a voice, using images, right? So all those different type of inputs has been enabled into the AI system or built AI system that has now understanding of human. That is coming up here. Next slide, please. Yeah. So what it achieved? So deep learning achieved the breakthroughs areas like image recognition and natural language processing. So obviously, so as I mentioned, the focus was the idea of deep learning module was to make a AI easiness with human language, and the output of the deep learning finally achieved. It's still work in progress. I'm not saying that it is fully implemented, but it's evolutionary process where new models are still getting evolved. Many new AI tools are coming up into the market, which are enhancing particularly this deep learning models and making their generative AIs more effective. But yeah, so the clear goal was AI to understand human language. Now today, we talk about a generative AI, and as I mentioned, generative AI, the name itself shows it generates a response to AI. So whatever the work that you wanted, whatever the ideas that you put into the AI, that gone processed through the AI, through ML through deep learning through. Now today, it responds what exactly the out it comes, right? And then it how it gives the output. It gives the output typically in forms of text, images, or other medias. Other medias are like videos. These days, I believe most of you are using some sort of AI tools like a ChatGPT, or a ChatGPT is the most powerful generative AI tool, which builds the things in shorter time. Like some of the content of these trainings, okay, I got it from the ChatGPT. So that is a beautiful. So it has created the entire PowerPoint presentation, putting it into the model, structurizing the documents. So it has happened for me. So in a way, generative AI is now pretty common. Everybody has started one another way in each field. So in a later slides, I have also outlined which are other sectors, or which are the typical sectors, or the role-wise, like how people are utilizing, what are the different tools that are being used in the industry, or which are the famous or popular tools in the industry. I have that information also captured in the future slides. Okay, so next slide, please. So now that is more on generative AI. As I mentioned, this generative AI, it has enhanced more on deep learning, specifically to the generative models, like a generative adversarial networks. Anybody knows what is this generative adversarial network? I've covered that in the later slide, but I just wanted to know if somebody knows what is generative adversarial network. This is basically the neural network, okay? This is basically a neural network, but what it does, it is categorized into two things. To make this AIs more popular, it is categorized into two things. So one is typically generates the response, but while generating the response, the challenge was system was not understanding or discriminating whom they are talking to or what they are talking to, right? So this generative adversarial network is smart enough to understand or to make a discrimination between different things, and also generate the appropriate responses for the AIs or for the queries that are come to them. Okay, so so that is how the powerful they made it Gen AI these days. Next slide, please. Okay. So now, little more about AI and ML. So evolution of generative AI. That is, move ahead with content creation, data augmentation, creative applications, and now which has opened exciting possibilities across the industries. So that is how typically AI evolutionary things happen. Next slide, please. What is artificial intelligence? That was the original question that I asked. AI is a simulation of a human intelligence processed by a computer system. It enables the machine to analyze and interpret the complex data, learn from the examples, make informed decisions, and also take decision. So these all things that originally we thought of with the artificial intelligence, and that is what it is. So what are these cases which are purely uses AI? Humanoid robots. You must have seen many industries where less error is expected into the production systems. There they use typically the AIs, packaging system, which is one of the beautiful example where humanized robots, they fold the boxes, put the stuffs inside, packs it, puts the label, and pushes it. Amazon delivery section, they are using all humanized robots, right? Then the cart monitoring, today the IT industry is fully dependent on lots of monitoring tool, which has further developed with the error monitoring systems, or error handling systems on top of monitoring. So if anything goes wrong, it gives you alert. Again, alert mechanism that acts as a as based on the severity. Like in industry, a production system, if any error pops up, which is not creating any kind of impact or less impact, it just gives you the alert on the system. If it has a moderate impact, then it is smart enough, or it is created the APIs to give the automated call to the different stakeholders who can look or pay attention immediately to clear off those more high intensity things. The senior level will get a call or whatever the mechanism is enabled on top of this monitoring system, and they are trying to reduce the impact on that, right? It's very common in the corporation these days. Now, creating the smart content. So like these days, most of all the contents are created using AI tools. Earlier, I remember in IT industry, we used to create lower design document, we call it as LLD, higher level design document, HLDs, correct? Support documentation for any application that created. So all those documentation we used to sit together, understand the architecture, understand all the parameters of the system, and used to create the content. But today, there's no need. You feed the architecture diagram, or feed any knowledge transition recorded sessions, and put those recorded sessions with AI, and it creates you the content the way how you want. You want to create a PPT version of those content, it will create. You want to run a Word document, it will create a Word document. If you want to create a video on that, or making more visual interactions, you can use that. So all those things are possible using this. So these are the very useful use cases that are typically we are using. Now, going towards machine learning. Can you go to the previous slide? Yeah. So where machine learning is? So what is the machine learning? Machine learning is a subfield of AI again that involves the development and implementation of algorithms, models, which enable the computer system to learn and make predictions or decisions. Machine learning helps to train computer system using large data sets. So as I mentioned earlier, so this typically works on larger data sets, larger different type of data sets, and it has intelligence to read the data that is provided, and it comes up with its own predictive analysis. Now, this analysis are the human error free. So, meaning what are the algorithms or what are the logics that are put into the programs? It it straight away executes without any human bias, and the analysis achieved by machine learning are 99.99% correct, unless there is a flaw in your workflows or the programs, algorithms that are written. But otherwise, machine learning is very powerful tool. And what are the use cases that where we are using machine learning? The customer churn, credit card fraud detection, and image classification. Now, beautiful example is on credit card fraud detection. So in a banking sector, machine learning has been used to understand what kind of the frauds that can happen on your different type of cards. For example, the credit cards. There are different types of credit cards again. So so what it does is it analyzes the data on individual person who is holding the credit card, not only the credit card information or not only the credit card holders of personal information, but also it analyzes that the person's location. I'm just giving an example, person's location. So if I have a credit card and my usage of credit card is most of the times in a location Houston, and if I move out or if I go travel somewhere, and if I do the transaction using my credit card, the system is used to learn the pattern of my data usage or my credit card usage, and it gives me the alert. The certain systems are more intelligent to stop the transaction. Most of you guys are using credit cards. You might have end up with similar situations where you are getting the message that, hey, your card has been swiped for this many rupees, right? Or for this store, your card has been used. If it is true, then reply 1, 2, 3, something like that, right? Those are the monitoring system that generates it. But it goes beyond, like, even if the fraud happens, who has used the card, where the card has been used, who could be the possible what could be the possible scenarios, whether the card was physically present or it was used as a proxy, right? So all those kind of algorithms are maintained, and it's a very beautiful case where they are using all this data that has been used by an individual user. All these are
So
achieved by.
just to add, Deepak, right, one more thing on the credit card fraud detection, okay? Um, so typically it also does the profiling of the user, right? What are their spending patterns, okay? What area of focus geographically, even from the market standpoint as well, right? So what typically these systems are doing nowadays, right? We are able to create a profile for each and every user, right, based on their spending patterns, based on what their geographical locations are. Okay, so this is basically aiding, okay, the system, the decision making system, right, to understand and gauge and highlight or flag the item which was Deepak was talking about, right? So it eventually reach out to the customer saying if there is some unusual item that has been identified or unusual pattern that has been identified, right? Where they ask, the authentic user, right, to validate that and authorize that transaction as such as well. So there are different means and ways there's these credit card fraud detection, right? Are being taken care for. Even the anti-money laundering nowadays, right? We are able to utilize, a more efficient way of AI, right? To see how exactly we can tackle on the anti-money laundering, which is much more deeper subject as I can say. Yeah, Deepak. Okay.
Yeah. Thanks. So the next case that I mentioned is about the image classification. So it is pretty straightforward. So what it does is uh, these days you might have seen if you open up your Google Maps, right? So Google Maps, it also evolved much now, but certain areas where there are images, those are uploaded in Google Maps. If you click there, it gives you a 360 view of the street. You know how that is coming? That is coming using the ML. So utilization of ML. So ML has it typically collects the collection of images at particular geography, and it gives you that kind of a view. So now the systems are made, certain systems are made so friendly that when you put up, say, you want to look for any specific food menu, it identifies that particular food menus are, or the pictures of this particular food menu looks like this, right? So it classifies your image for that particular tag and it gives you the output. And it's a simple example that I gave, but if you look at the larger utilization of that. So for example, like I work in the oil and gas industry, where the images, every time the images comes from different wells, those produces or those pumps the oil, correct? So there are fields which are created to drill the wells. So what happens is this image classification that is used to understand how much field is occupied, where all these fields are. Each well is very well named, and when you put that image into one, it easily diversify the output of your system, and it gives you like in 2 acres of land there are 4 wells drilled, and those 4 wells have ABCD name, and with the image I can get that what is the volume of oil extracted from each well. So that smart image classification that has been used in using the ML model. Now the data, basically it feeds more and more images to make our human interface or human interaction more fluent, more nice. Okay, next one. So that was all about AI and ML. So now typical differences that we, if we go to understand, so artificial intelligence is again, AI is a parent of machine learning and uses various techniques to simulate human intelligence. AI requires extensive domain knowledge and emphasizes on human expertise to design and execute intelligent system. Okay, and ML, next slide please. And ML is again a subset of AI that is focuses on development of algorithms, models that enable machines to learn and make predictions based on the data. ML allows machine to learn autonomously from the past data. Okay, I think that's been pretty clear, right? We're talking the same thing, but in a different angles, so that the concept fundamentally gets clear. Okay. Next slide. Okay. Now we are talking about the next two sessions. Those are deep learning and generative. This is very interesting. Okay. So what is though we already spoke about what is deep learning, what is generative AI. Next slide, please. Let's get more on this. Okay. So what is deep learning? So deep learning is a subfield of machine learning. It focuses on development and implementation of artificial neural networks inspired by structure and function of a human brain. Clear, right? It involves the training these neural networks to learn and makes the prediction and decisions. So it is a continuous responsive system to learn more, understand the human language. Wherever it doesn't understand, there is a scope of evolving, right? So in that way, the deep learning is getting evolved. Now, typical use cases of deep learning. Excellent example, speech recognition and speech synthesis. Most of you guys must have used Siri, right? Siri, or these days, I remember there was one of the movie where I know at that time the movie was made to bring up some comedy into it, but it was showed that the car starts with the driver's voice. If somebody else talks, car doesn't start, right? But that is possible today. Today, now deep learning is evolved in such a way that you can develop your system which can recognize your voice, which can recognize the command that are given to you, and it responds accordingly. Google Nest, or the Google system, which recognizes the human voice and gives us the responses. Dots, Google Dots, everybody is using, very common, right? So that uses a speech recognition and voice recognition, image recognition too. Now image recognition. So iPhone, classic example, which senses your eyesights to open up your phone. It recognizes your eyesight, which is gone beyond. Image recognition is the one which you can open up a system with a specific, or you can feed a specific image to recognize you, right?
So, Deepak, as you rightly pointed out, like different models basically which are being used, right, to drive different use cases. For example, we don't use the sword, right, to cut the vegetables as such. Okay. So same way, there are different, different mechanisms, tools, right, different models which are being introduced. And even now we are speaking, right, there are multiple models which get introduced as such. Okay. Like, for example, today we'll be talking more about bird, right? We'll be talking about llama, right? So which really goes back to like what the parameters that have been supporting, right, for that particular model itself. Like a bird, for example, right, it's very concise, very focused, right, and then the kind of use cases that it is driving, right, that really reduces the cost or even the latency, right, when we are talking about these AI models, right? So yeah, I think different use cases would warrant different type of AI models basically. And then the focus main is right to reducing the cost, reducing the latency as such, what kind of support parameters that they have, like, the kind of evolution that we have seen even for llama, right? The way that it started, currently we are looking at, multi-billion dollar, multi-billion parameters as such, right, which are supporting the llama. So why don't so just to add a couple more insight on the models, right, as well as the BERT and llama is concerned. So do you want to talk about that, or yeah?
Yeah, I have a specific slides related to that later. Let me cover up this. We
Excellent.
are
Yeah, absolutely, sure.
with the fundamentals. So deep learning, let me cover up generative AI. and then we will quickly summarize on the journey of AI, and then we will quickly jump into the specific models.
Absolutely. Thank you.
Yeah. Okay. Next slide. I'll not spend too much time on this as I have given the key ideas. So now generative AI, as I mentioned, is a type of artificial intelligence that is capable of generating the responses in terms of text, images, other medias. And this particular model, it is smart enough, intelligent, that to understand the patterns and the structure of the data that is receiving from AI, and it also responds with appropriate information by processing all the algorithms. Right? So typical use cases for that: the creative content generation, virtual avatars, very common these days, specifically in gaming, data augmentation and synthesis. Right? So we do lots of data chunks, lots of data APIs. We build the data from, or we get the data from different SORs systems, and do the synthesis on that to come to a final output. Have very beautiful examples that are utilizing these days. But yeah, everybody one another way is associated today with the generative AI. That's what I can say. Next slide, please. Okay. Difference between deep learning and generative AI. The next. We have already, yeah. So in short, deep learning refers to the subfield of machine learning. It focuses more on neural network and their ability to learn from data, right? And the deep learning has a broader scope of encompassness, various applications beyond the generative tasks. So as it is, built on ML, it has advanced generative tasks that getting understood and also getting responded. Generative AI, in a way, it responds. Okay. Now, a quick look on what kind of different types of deep learning models we have. So we have two types of deep learning models. One is a generative and one is a non-generative. A typical use case for generative AI is a speech recognition, text generation, all those using which understands the human language. That is what we call natural languages. It the systems that can understand and responds with the image, which can create a content in video or understand the video and do the analysis on video information, image information, and text information. All those are typical use cases of AI. Phone, our all Android phone, smartphone, right? All those are the classic examples which are utilizing all these different AI techniques. Non-generative, like numbers, discrete probability, working on the probabilities or creating the classes. All those are the AI cases which are non-generative, because it does not generate any response. Okay, it simply gives you the output. It doesn't understand the system or doesn't understand the language that that human talks. It purely gives you the output. What you put it into the logical way that a computer understands. So that's what the non-generative is generative. Okay. Next slide. Now, machine learning models. We have two types of machine learning models. One is a discriminative and generative. Now, again, discriminative means it's a discriminates and generative is a generates the response, right? Just straight away. But very smartly, we need to understand like how it creates a discrimination. What is the idea behind this discrimination? Why it came into picture, and why to make this generative AI more efficient. Why they introduced these models, right? So can you go to the next slide? Okay, so discriminative. So how it has been taken, it has first, put a boundary line. And here the example is taken like how the dogs has been discriminated from cat, right? So typically the model understands the image, right? It understands the image and we categorize this particular image as a cat image or dog image. We create certain data points for image to understand or to translate that data into the actual form where you are creating the algorithms or the programs that can understand it well. And then you create an interface, you build those taglines, and then your system takes the decision. Oh, okay, I read these images through, I read these properties through, I read these various parameters, and because these parameters are falling into more cat or more dog, I take a decision that this image is of dog, right? So that is how the discrimination happens. Now, as I said, I gave an example of dog and cat, but this discrimination happens across multiple animals or many animals. If it is data types, even in data types, it discriminates different data types, right? Images, videos. So like that, it makes your system more intelligent to take the appropriate decisions. And generative AI, now take the example of DALL-E 2. DALL-E is one of the most popular tool that converts or that gives you the output in images and videos, right? So when we put a demand or put a command to generative AI, say, hey, DALL-E 2, give me the generate a corporate office image, how it looks like when it is actually raining, and if there are the dark clouds, and also some associates are walking inside it. So generate me the image. So it goes to all the images, it collects all the images, and it builds you the image, whatever the output that you are expecting. And trust me, it is also up to a certain level. You can achieve that using your GPT tools as well, like a chat GPT. I remember recently we had a Thanksgiving event where I was asked to create the Thanksgiving events invitation cards, and I generated this invitation cards using ChatGPT. I specifically give a commands like, hey, ChatGPT, I want an image that is covering the information of this event. The event is happening on this date, this time. Food will be like this, and these are the activities. So I put it for all the things, and it created a nicely a good a card, e-card, and I readily used that card and sent it to all. So those kind of a usage are pretty common. Okay, so can you go to the next slide? Okay, and now in generative AIs, now we have two different classifications. One is a generative language model and image model. Straight away, language model, it works more on the text or the voice recognition or the voice text conversion. Typical tools used, ChatGPT and DALL-E 3. Generative image modeling, which used more on the image processing or understanding the image, uses all the concepts that I mentioned, like discrimination, understanding what is what, and analyze the different type of imaging data. Typical tools used are Synthesia and Google's GBAR. Okay, so these are the common tools used in the market. Next slide, please. Important generative tools again, apart from that, I thought of highlighting 4 commonly used tools. One is ChatGPT, Bard AI, DALL-E 3, and GitHub Copilot. Next slide. So typically, ChatGPT stands for Generative Pre-trained Transformer. It receives the data in the text, and it responds. Like these days, you might have seen there is a chatbots, right? So most of the service providers, starting from banking to retail, right? Everybody has their chatbots, which has a predefined questions, predefined guidelines, and whoever is seeking for the request, they just have to put their questions, and system is smart enough to understand that text, and by understanding it also enough capable of providing the responses. So that's why the ChatGPT is one of the best tool. Dialetry, as we spoke about, that is works on the OpenAI. It can generate a highly realistic and coherent images from textual descriptions. So whatever you say, it generates the images. It takes the images from different places, and it brings it all together to you. DALL-E is again is a nice tool. Next, Bard AI or GBard. It's similar to ChatGPT, but it has excessive chatbot AI that can use the natural language processing and machine learning together to enhance the understanding experience. It also has an interface for the utilization of LLMs. Then this LMDA and Palm 2. Now those are used to create the creative tasks, and get the output on your commands more creatively. It is basically the similar to ChatGPT, but uses a complex workflows. It answers you, or it generates you the responses for the complex queries. GitHub is well known. It's very common in developers. It's so developed so efficiently that that a developer can generate their codes using GitHub Copilot. Next slide.
Right. Even, just to add to that, right, there are different API interactions or integrations that are being supported in these AIs where, for example, in GitHub Copilot, right, it brings the OApp's top 10, security parameters, right, or security suggestions or best practices as such, okay, within the environment or ecosystem, which would eventually help the developer, right, to create the, secure code, right, I would say. Even there are different ways that you can test and train using those API suggestions as such when you are developing the code within the GitHub Pilot. So they have really provided an efficient integration which will eventually actually eventually optimize the way that the coders used to develop. Okay, providing them the suggestions, a better way of writing the code, right? Optimizing the number of lines being written, increasing the throughput, right? Reducing the latency as such. Okay. See, at the end of the day, what we are talking about is what is the cost associated, when I'm using the AI model, right, to solve a particular problem, as we, spoke about very briefly at the start of it, right? Where we don't use the sword, right, to cut the vegetables. So what kind of, the problem statement that you are having and what kind of AI model is useful to support that particular problem statement or resolve that problem is important. Yeah, yeah. Deepak.
Yeah, you can move on to the next slide. Like it is mostly talking about how the architects or the developers
Right.
are using AI.
Right. So different
in
different roles that we typically see, right? In terms of the developers, right? The architect, consultants, for that matter, and then what type of information is required by pre-sales or sales. Even, the kind of content which are being generated at the different stages, right, are being supported by AI itself, right? Where they play the role, what we need to think more about is, right, what kind of prompt that we are asking for AI to take forward, right? Again, you also need to think about the prompt injection attacks, like the input validation attacks that typically happen. So there are both side, that you also need to think. One is the availability or usability of the given AI model, and what is the security support features which are being offered by the AI model. Okay, up to what extent that we are really talking about. Is there any data poisoning that that we are looking at? Is then how can I restrict my data within the confinement or the segment? So all those thought process that goes on, right, when you are playing different roles, right, as far as the utilization of AI model is concerned. So like developer, architects, right, consultants, everybody has the a different point of view. Okay, different AI model basically used to support them, provide the right information, and resolve the problem statement that they are typically having. So it goes like, for all the type of roles that we are really talking about, right? So Deepak, do you want to take that?
Yeah, I'll quickly cover up. There are lots of things to talk at each thing, but yeah, typically in IT organizations, the generative AIs are being used for the code generation, as I mentioned.
Right.
GitHub Copilot is predominantly used for code generation. Then in natural language processing, we covered up about understanding the commands, the human commands or human language. So those are utilized. Software security, with the wide usage of AI these days is into software security.
Right.
And then bug detection, user interface, all this type again. It's just kind of a development things, automated code reviews, automated testing, performance optimization, automated documentation generation. These all concepts I covered in previous things. But yeah, all those things are getting the benefits. And I also talked about why we are using the generative tool more advanced by using the generative adversarial network. So general adversarial network is, specifically, invented to make the AI more effective because it generates as well as it discriminates, right? And different type of things that it covers, like a text, code, image, speech, video, all this. Now, this slide I'll quickly cover up, but
Do you
try
want to
to.
go to BART or which one?
Yeah,
Like this
let's
one?
go to
Yeah.
that.
Okay. Like GPT BART.
Yeah.
Okay.
Mhm. So,
Yeah.
introduction to the fundamental models. So here is the overview on the GPT, BERT, and LLMA, like where it is used now. We all talk about the AI models, GPT. So GPT is what GPT is, what BERT is, what LLMA is. So GPT is generative capability. Yeah, Ganesh, you want to cover?
No, I think somebody was talking about. Yeah, go ahead.
Okay. It's producing the coherent and contextually relevant text-based inputs prompts, powering automated content generation. But what the BERT is, BERT uses a bidirectional approach. Now, in all this GPT, BERT, and LLMA, BERT is the only one which is a bidirectional. Okay, what bidirectional means is it understands the right to left, left to right, but other two are single direction. Okay, so in that way, BERT is bidirectional. It has a bidirectional approach to understand the context. It also ideal for the tasks like answering the questions, or if your questions has some sentiments into it. It is up to a certain limit. It is enough intelligent to um, understand the sentiment of the question, right?
I think it is pretty much focused, right? What the problem statement that you are having for bird is, right? See the kind of number of parameters which are supported by bird, right? Around like 100 million parameters, if I'm not wrong. Okay. But then the kind of cost and latency that it brings to the table, right? So given that the number of parameters are less, right? So the focused approach is very essential for the problem solving using BERT, right? I think that is something that we, as opposed to llama, right, which typically nowadays, like if I'm right, like uh, around 2 trillion parameters are being supported by llama 4 model, which is the latest model that they are currently having, which is a multi-model support that is offered by llama as compared to BERT. So what type of problem that you are trying to solve, right, is something that what AI model is essential, something that you would be looking into key parameters that you need to think about, right, when you're choosing any of those models. One is what is the cost associated with it, what is the latency, like how much amount of time that it will consume to execute or resolve that particular problem statement, the kind of support, the number of parameters that it require, right, to conduct that one, and then the security features, including the integration, including the security best practices being followed, right, whether it is used to compartmentalize or not offer any data leakage as such through that particular model, right? So what kind of what kind of predictability that it brings to the table, what kind of analysis that it brings to the table. Yeah, go ahead, Deepak.
Yeah, that's pretty good. Can go to the next slide. Okay, so this talks more about architecture and capabilities of GPT. So it has a transformer. What is a transformer architecture? So it transforms the things from one form to other form, right? So this GPT uses a transformer architecture with self-attention to efficiency process and generate the context aware text sequences. So it basically understands what sequence that your text inputs are coming in. It understands, it generates the specific responses based on the architecture that has been created under that GPT. It also have a autoregressive language modeling. So what is autoregressive language modeling? Is that model which predicts the next words in the sentence based on the preceding context and produce the coherent and relevant text. So like what happens is, give me just a minute.
Sorry, Deepak, you there?
Just hang on a minute.
Okay, sure.
Hello.
Yeah. So sorry. So
Yeah. Okay, okay. If you're taking time, can I ask something to Ganesh? Yeah.
Yeah, go
yeah,
ahead.
sure.
Yeah. Like you are working in security and architecture.
Yes.
Yeah. So like maybe not related to this, but yeah, like why it is so why we are finding very less people in security and architecture and very low model like models is still like whatever we are doing in AI and LLM,
Right.
we are still struggling in security.
Indeed. So see, because the first, okay, so first you need to understand, right, how security gets involved. It is pretty typically the CIA triad, right, confidentiality, integrity, and availability. Okay, now that is applied pretty much everywhere. Now the challenge that businesses are focusing, right, is that from a availability point of view. Obviously, business has their own focus area, right? They want to venture into new business domain, right? Try to utilize and test the new technologies as such. But then um, uh, uh, the moment business start thinking that security is an aftermath, right, saying that it is an additional thing that is happening, it is dragging my business focus, it is dragging my business space, right, that's where the problem starts. And hence we found like we find very less people which are being exposed to the new technologies. When it comes to the to the security space, security world, eventually everybody has to come to security world even before being rolled out into production. Otherwise the cost of remediation goes huge, skyrocket. So eventually, due to regulatory requirement or policy requirement, or even coming back to the security space, people normally come at the later stage of it, right? So now people are realizing it, and they are involving
अमर
security
पाटिल को
architect.
मैसेज करो कि 5
Yeah, I think Deepal, you are on Unity one. But Rishi, is that Rishi? Rishi, we
Yeah,
can
yeah.
we can discuss at length as well, right? Or if you want to know more about it, we can. But I can tell you right now, we are seeing the change that is happening. Okay, where security architects are getting involved even at the inception, at the design level, at the the idea when it has been originated by the business. That's when the security architect are given, and I am the testimony of it, by the way. Okay, so I can vouch for that. So now I can see the change that is happening around, where we are having a say right at the idea stage, and we are enabling, security is enabling business to do it more efficiently and securely, right? So that the cost of change is lesser later on. You know what I mean? But if you want,
Yeah,
if you have more queries, right, feel free to
yeah.
ping me. Yeah.
Yeah, I'll connect with you.
Absolutely, sure. Would be.
Thank you so
Thank
much.
you.
Thank
Yeah.
you.
Okay, cool.
Yeah.
So we're talking about the BERT and its application. So as I mentioned, the BERT is bidirectional, which can read left to right, right to left. Meaning is it deeply understands the relationship. Sentence, it has intelligent enough to understand the sentences, and then it helps to draft or respond in appropriate words or the languages. Right? Then how does it do? What model it uses? It also not model, but it also uses the masked language model. So meaning the sentence is nothing but sentence is a masked words, right? So when you put the words in a certain sequence, it is smart enough to understand those words, the sequence, and then understand the sentence, and then based on the understanding, it creates its predictions, and create the semantic meaning for the responses, right? So all those things are used using the master language model. Then next sentence production, as it is a sequential process. What it does, the text understands the sentences. It not only understands the sentences, but it also understands the relationship between sentences for the improved language comprehension. So for example, if any text input is coming with inappropriate grammar, or has a grammatical mistakes, right? It has capability to autocorrect and respond appropriately, right? So it has that next sentence prediction as well. Then the applications and the variants. So when you have this NLP is going. NLP is a normal language. So when your normal language is processed, like the questions are asked, and then it goes through the master language modeling. It does the prediction analysis for the next sentence or next word. It also understands the sentiments using the application variants, and that is how it is creates a powerful response. The tool like Robota is one of the good a tool that uses a BERT mechanism for their responses. Now, LLMA, which is the open source accessibility, So this LLMA is typically for the prompting, accessibility, and community-driven innovation AI in AI development. What model it uses? It uses the flexible model sizes. So what is the model size here? What is the data handling? Data handling capacity 7 billion to 70 billion. So Ganesh was explaining you like all these different models that are being used in AI are used based on individuals' requirement, typically to understand what are the cost efficiency and the requirement that you have. Like if you have a lesser requirement, or your code base or your database is data handling capacity that you are predicting is lesser, then you can go with the GPT model, right? If the data is little more, like 70 billion, then you can use LLMA. Now, with LLMA version 4, it has a capability to handle data interlinks. So, but this model is pretty much flexible and very popular as well. It has a very good performance. So, its architecture is designed in such a way that it has a different individual buses that that enables this model to process the multiple queries in one go. So it acts like a real-time processors. Those kind of capabilities are enabled into this model architecture, and which makes it more faster. Provided again all the model or the AI tools efficiency is totally dependent on what kind of hardware that are used to execute, what kind of data that has been processed through to get your individual outcomes, and also what kind of a network has been used to connect the different users. So all those things are involved into it. These days, the hardware, most of the organizations are utilizing the cloud. So hardware-related challenges are minimized by using the optimized clouds, where whatever the hardware is required, this has been altered or enhanced using or reading the different type of monitoring parameters or the alert system mechanism, right? So, but but LLMA is powerful because of its independent process handling architecture. Okay, and then it also creates the versatile application. Can you go to the back next slide? The last point, let me cover. Yeah. So it creates the versatile application. So as you know that it trained on the diverse data LLMA platforms. Those will be good in the text generation, summarization, and translational tasks. Right. So translational tasks like that. Google Translation is another good example of carrying out this translational task. Now, those are very lightweight tools, Google Translation and all. But the real-time translations from different language systems, understanding from human language or NLM to machine learning, those kind of translational tasks are huge, and certain applications that are going through the bigger or larger data sets using LLM, getting the output, taking the decisions out of it, and then feeding it to the application. It's really a powerful or complex activity that we perform through LLM. Okay, so training inferences workflows. Now these are the typically concepts. What is the training? What is the inference? Right. So when data is been processed through different models, those are typically either a training data or the inference data. So what happens? The training data is a data ingestion for data related to the tokens, mask the data. So we will talk about all these things, and it goes into that. But inferences are the actions on it, like understanding, decoding, putting the guardrails, observe and give more detailed limitations. So all those things comes into inferences. So this is how the data has been handled in the different. It's just some concepts that makes your models more robust. How you are handling your data. Okay. Next. Yeah. Now differences in all these different type of models. What GPT is, architecture-wise, GPT is a decoder. It's only a decoder, but is an encoder. It's only an encoder only transformer. LLM is a decoder only transformer. Why BERT is encoder? Because it is a bidirectional. So that is where the BERT is more effective in terms of those cases. Objective of all, like the GPT is used for autoregressive next token prediction. BERT is used for masked LM plus next sentence prediction, and LLMA is used for autoregressive next token prediction, but with the large data sets. Typical tasks in GPT, those are text generation tasks or generic summarization. And I'm using the word generic because it has a limitations in GPT. Okay, but it gives you the classification, NERs, QAs, search ranking, all those facilities it gives you in input. LLM is similar to GPT, but it's more on a generation of text, instructional following. So because it utilizes more complex workflows, and then RAGs. Sizes, as we mentioned, GPT uses comparative to other two models, it's a lower data handling. BERT that uses typical 110 million records to 340 million records. And LLMA, where LLMA2 specification, where if you take, it's from 7 billion to 70 billion. But in LLMA4, which is the latest model, it has a capability to handle 4 trillions of data.
So this is what we were talking about initially, right? What is the number of parameters which are being supported within this particular space? Like for example, Llama 2 and Llama 4 now is supporting 2 trillion parameters as such. Okay. Now there are pros and cons of this, right? One being, right, how much predictability analysis that can be supported by that particular model, right? And that would eventually result into cost and latency. That defines which model that you're gonna use it. Okay, cool.
Okay, I think
Deepak,
we are.
yeah, okay. So if any questions that you can drop a note on email ID that I shared. If any additional follow-ups, right, please let Deepali ma'am know about it so that she can engage further as well. So excellent. Thank you, Deepak. Thanks for your time. It was really insightful and helpful. And thank you, Deepali ma'am, for organizing this. Yeah, Deepali ma'am, over to you.
Yeah, thank you guys. Yeah, do send us questions if you have.
Thank you so much, sir. The session which you have provided a comprehensive and structured overview of the evolution of the foundation models. Your explanation on the evolution of models, GPT, BERT, and LLAMA, along with the real world application and future research directions, they greatly enhance the participants' clarity and understanding of the large scale language models. We are very happy to have both of us. You have joined us for sharing your knowledge with the participants. Thank you so much, sir. For any
Thank you.
queries, the participants can mail the queries on gng0120@gmail.com. This is the email ID of the Ganesh, sir.
Yeah, sure. Thank you. Bye.
Thank you, sir. I request all the participants to kindly switch on your
इसमें वो
camera
नहीं
for
आ
the
रहा है
group
चैट
photograph.
बॉक्स हमसे कहाँ चला गया
Can we get the LinkedIn profile for both of the
Sure, sir. We will share the LinkedIn profile on the WhatsApp group so
Okay.
that you can contact them directly. I request the resource person, Ganesh sir and Deepak sir, to kindly switch on your camera as well as the participants for taking the group photograph. So our next resource person has already joined us. Now, Mr. Amol Patil is going to conduct the next session, which is based upon the basics of the deep learning, perceptrons, CNN, RNN, transformers, and the attention mechanisms. So before starting the session, let me introduce you to Mr. Amol, sir. Amol Patil sir is a dedicated technology professional based on the Pune, Maharashtra, with hands-on experience in IT support, technical services, and data-driven problem solving. Currently, he is working as a co-lead and the master trainer at Edu Foundation. He is skilled in harnessing the data science capabilities, contributing to the data-centric decision-making and problem solving. Amol sir has successfully applied the machine learning techniques to various projects, delivering the outstanding results. Amol sir has proven the ability to manage the technical challenges, provide the reliable user support, and ensure the operational continuity across the complex enterprise environments. Sir has also developed his career through a diversity of roles spanning the IT support, customer service, and the AI expertise. Before his current role, he has contributed as a CRE and the subject matter expert, where he has partnered with the cross functional teams to solve the client issues, streamline workflows, and enhance the service quality. Amol sir has also handled the troubleshooting of the technical issues, supporting the system's user with effective solutions and helping maintain a level of support performance, ensuring that the stakeholders and the learners they rely on the digital platforms receive the seamless service. So with this, I am handing over the session to Amol Patil sir, so we can start up with the session.
Yeah. First of all, thank you, Shalu ma'am, for giving the introduction. So let me start this session. Just a moment. Let me bring my screen. Hope I'm audible to all of you.
Yes, sir, you are audible.
Yeah. Thank you for the confirmation. So now let's start this session. So as you know, we are going to start the session from the basic of the deep learning. Okay. So just give me a second. I'm requesting all participants to mute yourself so that we can start this session. Yeah. I hope my screen is visible to all participants. Can anyone acknowledge me? You can unmute or you can use the chat as well.
Yes, sir, visible.
Yes, sir, it's visible.
Yeah. Thank you. Thank you for the confirmation. So now let's start this session with a very good vibes and the high energy, right? This is the night, but right, we'll give our best to get more insights about the data science and the recent trends in the AI. Okay, so now let's start this session. Yeah. So we're going to start first about what are the recent trends in the AI and what is the data science, right? So that is the main theme that which we have for this FDP. So to discuss these things, right, as we have discussed what is AI in the last uh, session. Okay, so now we are going to discuss about how these models are built, right? We have discussed about the LLM models, then we have discussed about the GAN as well, right? Generative Adversarial Network. Everything we have discussed, because we don't know what many of you might be not aware about this term, but we'll discuss everything from the scratch, how we can build the models, right? What are different kind of models that we have. So we are going to discuss each and every terminology which is associated with the models, right? So that's the reason this the picture which comes into the picture, the fundamentals of the deep learning. Okay, because to work something, we should know how these things are work. In the background, right? If we don't know how this works, let's suppose we are riding the bike and we don't know how the engine works, right? So we have to discuss in detail how this engine works and how we can utilize those things to get some decisions, right? So let's discuss about these things in detail. So we are going to start with the very first topic, right, which is the fundamentals of the deep learning. Yeah. So let's discuss about the objective, what we are going to learn in this session. So these are the objective, as you can see on the screen as well. Mm, we are going to start first with the image classification using machine learning, right? So because the thing is that first of all, we should know why we have to use deep learning if we have the machine learning, right? That should be our main concern. If we don't know that what is the disadvantage of using machine learning or the deep learning, okay, we cannot go with the next terminology, the next technology. Okay, that's the reason we should first focus on the what is the limitations of the machine learning and why we cannot use those things. Okay, so after that we'll discuss about the deep learning, right? What the deep learning is all about. Then we'll discuss about a very interesting terminology, which is CNN, okay, convolution neural network. And for the CNN, I have one, the basic hands-on practice that I have aligned for you so that you can understand these things in the detail, right? Then we do have the arrogance, and the last but not least, the modern DL trains, right? What are the deep learning trains that we have? We can discuss on that. So this is something about the objective that we've discussed. Now let's focus on the image classification using the machine learning. Okay, so before that, I'd like to know from your end, right? Can anyone tell me what are the limitations of the machine learning over the deep learning? Yes, over to you. You can use chat as well as you can ask me in the you can unmute yourself. That's fine for me. Yes, anyone?
Machine learning requires large machine learning limitation is no, it requires no minimum data sets, but deep learning requires a huge data set.
Wonderful, very good, right? That's the correct answer, right? We do have the models which is trained on the machine learning, but that are failed on some cases, right? Just mentioned by the sir, right? That
Lack of
not yeah.
explainability.
Exactly, right? See, whenever we are come to the machine learning, right, there are some set of limitations are there as discussed by this, right? We can train on the images, but if we do have the lots of images, then in that case the machines are failed. Okay, so now what do you mean by images? Let's focus on that, right? How we can classify an image, right? Because most of the times we do have the problems with the image classification, right? We do have these things. So let's discuss that how this image looks like, and how we can use the machine learning to solve that problem. Let's first discuss about what is the problem in the machine learning. Okay, if we have problem, then we can come up with the solution for this. So now image classification is the task of assigning a label or the class to the entire image. Okay, so this is the image classification in the simple terms. Now let's discuss how can let's illustrate this with a very good example. Okay, so I just want your support for this session so that that will bring the interaction between us. Yeah, so can anyone tell me uh what is the name of this pet? Yes, anyone? Come on, cat, right? Yes. Thank you, ma'am, for acknowledging, right? So cat is there, right? So let's discuss how this cat is there, right? This is the image of the cat, which we are seeing right now in the screen. Yes, wonderful. I am really glad that all the participants are, interacting with me. That's really nice. So now I'm going to give the label to that particular pet. That is a cat. Wonderful. So now we have classified that image as a cat by your human brain, right? Now let's focus with the next example. So can anyone tell me what is this object? Truck. Very good, right? We do have truck over here, right? Wonderful. So now I'm going to label that thing as well again, a truck, right? So now let's focus, right? How this computers see this truck, right? So let's see that how computers can see, and we can do the classification, right? With the help of the machine learning. Okay, we'll do that. So now let's focus on this next upcoming deck, right? So now we'll understand how these images are converted into the tabular format, right? Let's suppose we have the image of this truck with us, and we are going to cut these images into the pieces, right? As you know, right, images are nothing but, can anyone tell me what is the image in simple language? What is the image?
It's a white color.
Pardon?
Collection of pixels.
Collection of the
So,
pictures, right? Yeah, wonderful, right? Picture presentation is wonderful.
in 2D array.
Yes, exactly, right. So we have the 2D array for the grayscale, but for the color images we do have three channels, okay, which is the RGB channels. Okay, so see now this images are nothing but if I'll have one image, right? This is the image of the truck. I'm going to convert that into the pieces, right? So let's do that. So this is the truck, and I'm going to cut that into the pieces. See, now we do have the image, and I have cut that as per the height and the width. I'm going to cut those object of the truck, right? So see, so can anyone tell me, this is the first pixel. So what will be the value of this first pixel here? Yes, anyone? I have pointed out with the red mark. You can just tell me if you know.
0, 0.
No. For the black we have 0, right? And for the white we do have
Hello, ma'am.
225.
One.
Hello,
Wonderful,
ma'am.
right?
Hello.
255.
Am I audible, ma'am?
Yes,
Myself,
yes.
Dr. Devashish
Yes,
Chakraborty.
yes.
Hello.
Yes, you are audible.
Generally, an image has two types of information. One is spectral and spatial information. So, which one you are considering here?
I'm talking about the picture here, right? Let's suppose we
No.
have
You are considering spatial information or spectral information?
spectral information.
Spectral, not spatial.
No.
Okay.
Yeah. So let's suppose see, right? We do have the black color over here. So for the black color, we have the things, right? 0 is there, right? For the black color, we do have tires, and for the white color, we do have 255, right? So this is the value for this. So now this is something we already aware about these things. Now let's discuss how we can convert this image into the tabular format, right? Because for the machine learning, we want the data in the a tabular format where we do have the features and we do have the targets, right? So let's do that. So for this image, I'm going to convert that into the the tabular format. Let's do that. Yeah. See, now this is my image of the truck. One image, single image. I'm going to convert that into the one matrix, right? This is the matrix. I'm going to convert that into the one vector. So to do so, I'm going to put all these rows on the top of each beside, right? Like this. So this is now my one image of this truck, right? So for this is one image, right? And I'm going to do that for the different images as well, like see. So we do have the second image, and I'm going to put that truck label at the last, right? So this is the thing that we have with us. So this is the second image, then third image, and likewise we do have, let's suppose we do have 6 image and 7 images for understanding this concept, right? How we can make it into the tabular format, right? Yeah. So see, now can anyone tell me in the machine learning, if we do have such a data with us, so I have indicated one, the curly braces over here. So can anyone tell me what we are talking to this particular terminology? What is this all about for the machine learning?
Fields, sir.
Pardon?
Fields.
Fields. Okay. Apart from this, anyone?
Features.
For the machine learning, right? So this is nothing but the features, right? If you are able to recall whatever you have learned, right? Then this is the feature we do have. Let's suppose we have ages, right? We do have the salary. These are the features for any model, right? We are going to consider inputs.
Spectral bands. You're talking about that, right?
Right. Yes. So see
Spectral bands.
now.
These are the features.
Now these are the numbers which we have with us, right? So you can see right here we do have the matrix with the numbers. So these are the input features, and the last we have store it as the label, right? Target we can say. So this is nothing but the multiple images which we have. Now we can solve this problem with the help of the features and the target if we have. So x train, xy, we know already x and y we do have. The features are nothing but x, and target we have as a y, right? So we can do that with the help of this particular thing, right? So now I have tried that on the different things, right? So I have tried that. So I have tried with this data set with me. So the what is the problem? Like we are discussing the problem. What is the problem with the machine learning? Okay, so what I found is that I'm getting the very less accuracy. Okay, I have used the Canon model for this, but I'm getting only 34% accuracy. Okay, I have used the machine learning. As you can see on the screen, as for the every classes, we do have some score, R1 score, then F1 score, then recall the precision, everything which we have. But this is not the correct way, right? So for images, I'm getting this kind of accuracy. As someone mentioned, right, previously that that's the reason we should not go with the machine learning. Okay. So yeah, now let's focus on deep learning. That's the reason the deep learning in the come into the picture. Okay, let's discuss about this. I have tried that with a one image. As you can see, right, this recommending us that this is the image and image of a bird, right? But it's not recommending all time. So that's the reason we should not go with the machine learning. So now let's discuss about the deep learning in detail, how this work, and how we can utilize these things to learn many more things. Okay. So before that, I want to ask from my end that if you have any questions, yeah, please let me know so that I can answer. Yes, anyone?
I have a query. Hello.
Yeah. Please go, sir. Yes.
Yeah, you have shown that the KNN classifier has very poor classification accuracy, that is used 34%. But in my case, I have worked also image classification where I have used the KNN classifier, and that provides a very good accuracy. But in that case, I have normalized the data pixels, that is between I think it be 0 to 1 or minus to 1. It provides a very good result.
Okay. So, yeah, that might be the case, right?
Because KNN is a very good classifier and provides good accuracy.
May I know, sir, what dataset do you have used? You have used the same dataset that which we have for this?
No, I have used image of Mumbai city and image of Kolkata city.
Okay,
that includes the also Hooghly, that contains Hooghly River also. And we have used KNN classifier and provides very good result.
Yeah. Okay.
So accuracy, I think, depends upon data set. What kind of data set you are taking?
Yes, right. Exactly.
And in that
That's
case,
what I'm talking about.
I'm telling you there are data set that that is the image. It has 4 bands: red band, green band, near infrared. Only 4 features, and there are 7 classifications, right?
Okay.
And in that case, we have normalized the features.
Okay, so that is again a very good technique, right? If you want to increase the accuracy, right, we should use some parameters. We can do the fine tuning. We can use the the normalization to improve the accuracy. But after doing all these things for this data set, I'm not getting the good accuracy, right? So that's the reason, right?
And that paper our work was published in ISPRS Journal of Photogrammetry and Remote Sensing, that is LCVS journal, and another is published in Pattern Recognition Journal, that is I think.
That's really nice, sir. That's really great that you have published papers. That's wonderful. Yeah, MC, right? I'm very happy for you. Yeah. Yeah. So now let's discuss about the deep learning, right? The what are the things that can we do with the help of the deep learning? Okay. So yes, thank you, everyone. So now let's discuss about the deep learning. How we can learn this thing in detail, right? So deep learning, also known as the deep structured learning, it's a part of the broader family of the machine learning, as you can see, right? In the image as well on the right hand side, we do have this image. We have seen this multiple times. So I thought that we should go with this only. So this machine learning is, it's a subset of the AI. And if you check the deep learning, it's a subset of the machine learning. Okay. And again, the generative AI is a subset of the deep learning. Okay. So this is, the hierarchy as we already know, right? So it's a based on the artificial neural networks. So learning can be supervised, semi-supervised, or the unsupervised. So this is the deep learning. Now let's focus how we can, use those things and what are the comparison between the machine learning and deep learning. Yeah, wonderful. So as we have seen, as you can see in the picture as well, for anything, as you can see for the machine learning, if you want to build the model which can classify the images, right? So we have the image of the car, and in the machine learning, what is the thing? We do have to do the feature extraction manually. Okay, so let's suppose we do have some features with us, uh, and we do have to do the feature extraction, right? So that is the something called manual process, right? So it's consists of the statistic as well. We can use the p-value, then we can use the ANOVA test, and there are many tests out there, right?
Hello,
T-test,
hello,
Z-test.
ma'am.
Yes, sir. Yes, sir.
There are other feature selection algorithms are also there. That is
PCA, right?
consistency based feature selection, kernel based feature selections that can be used also. That is feature selection. We can select some important features by using the
definitely.
algorithm. After that, we can classify after selecting the features.
Right.
Okay.
Exactly.
So,
Yes.
like
Right,
you
sir.
know that the SBM RFP also that feature description is done at the same time classification also. And that is the process also. That is the in case of machine learning, feature selection is done manually. After that, the data set is used for classification. Thank you.
Thank you, sir. Adding such a great points to the things, right? It makes your very interactive session for all of us. Yeah, definitely. Apart from this selection, right, we do have something called the feature extraction process also there, right? Let's suppose we do have the PCA, right? The principal component analysis which we are using, right? We do have the LD as well for the supervised learning, right? We do have multiple things, but that are not up to the mark sometimes. So that's the reason we should go with this. Again, for the large number of data set, machine learning sometimes fail, and it can only predict that is car or not, right? And again, a deep learning, it's having very versatile things within it, because it uses the different hidden layers, right? Which having some different complex networks there, and that can predict, if you'll pass the image of the car, it will not only give you the car, but it will give you the model of the car. Then it's shows the color of the car, and not it's also classify is it car or not. Okay, so there are multiple things we can discuss about this, right? So deep learning, it's prefer over the machine learning for the if we have the millions and the billions data set with us. Okay, so that's the reason, right? We should discuss these things in detail, right? Again, I like to add few more points over here. Like suppose recently the people are using, the pie carrot for this for the machine learning. Okay, we don't have to use the models which we have like the RN, the linear regression, we do have the classification algorithms like SVM, support vector machine, ensemble learning, then random forest. There are multiple things, but nowadays people are using, the Atto AI. Okay, so similar manner, we can use something called Atto Keras as well to build the model. Right, we don't have to worry about which model should I select or they choose for the particular data set, right? So that's the thing, right? We can discuss this things later, but I just like to add this point. That's the reason I have added here. Now let's focus on the deep learning neural networks, how it works and what are the different components are there, right? So as you can see, we do have some layers in the deep learning neural network. So hierarchical organization of the neurons with the connections to other neurons is simplified representation of the DNA. Okay, as you can see on the right hand side as well, we do have these things, right? So just a moment, let me clean this. So we do have something, because someone is doing this. I'm just requesting, please do not change all these things. Just a moment. I clean this.
Use whiteboard option.
Actually, I'm using this only. Just a moment. Sorry for the interruption. Yeah. So now let's discuss about, what are the different things that we have in the deep neural network, right? So if you check here, we do have something called neural network, right? So we do have different layers. On right hand side, you can just see we do have input layer, then hidden layers and the output layer. So these are some layers which we have with us. So on each neuron, right, there are different neurons are there and you can use these things. Okay, so deep neural networks gain their name from the fact that they are utilize a lot of the hidden layers to learn more intrinsic patterns, giving them the label and the deep learning. Okay, so as you all know, right, machine learning as well. Why we are using it? Because it will detect the pattern, and by detecting the pattern, we are able to get what this object is all about, right? So similar manner, we can detect the pattern as well over here, and the based on the received input, these neurons send a message or signal to the other neurons. Okay, so just like our brain, right, we do have brain, and on the brain we do have the different layers. Okay, so for the different layers, our eyes are connected to the brain, right? Whatever we are visualizing the things, whatever we are seeing the things, so rays are coming to our eyes, and after that what happens, uh, that the visual signals are processed by our brains, right? So that something comes into the picture. For a neuron, we do have the dendrites, we do have the axons, right? So everything you're aware about, like let's suppose discuss these things. So each neuron is connected to two other neuron. This is the fundamental analogy of the human brain. So just like that, they have come up with a very good analogy. Okay, something called the components of the artificial neuron. Okay, so how these things work, let's discuss these things in detail so that everyone will be aware about these things. Yeah, so see, we do have input layer, right? Here you can see x1, x2, x3, xn. These are the features we can say that we have, and each feature we do have associated with the different weights are there. Okay, so w1, w2, w3 and wn. So these are the weights. So all these weights are associated with the neuron. Okay, and we are going to we are going to do the summation of all the parameters that we have here, and then we are going to add the bias.
xi wi plus b.
Yes,
Summation
yes.
xi wi plus b.
Yeah, right, right. So yes, we do have these things right with us, and as we know, right, there is some equation of the linear regression, right? Y equal to mx plus c. Okay, similar manner we do have one equation, right? We can calculate that here. Y equal to, as mentioned by sir, x1 into w1, right? Plus we can do, and once we'll do all the things, we'll get one equation. once we have done these things, we are going to add the bias to this, right? Then once we have added the bias, then it will pass through the activation function. We'll discuss what is the activation function is all about. Don't worry about this. And then we are going to do the prediction. Okay, let's suppose I'm passing the few things over here, and my accuracy is my predicted value is not as per the the test value or the actual value. Then this error will be again back propagate, and then we'll get these things, right? Yes. So this is the components of the artificial neuron that we have with us. So now already we are aware about these things. Weight, what is the weight? It is nothing but the slope. Just like the in a linear regression, we do have the slope, right? So like just like that, we do have some parameters called W1, W2, and this W1, W2, W3. These are the very essential for the building a neural network, because these are the weights. Okay, and for the back propagation, these are weights get updated for every each cycle. Okay, so this is the one thing which I would like to add. Now, coming to the second thing, which is the activation function, we'll discuss about this. What is the activation function does, right? So talking about the activation function, so see, whenever we are listening something or we are watching something, sometimes what happen, some voice are not coming to our brain, which is not reached to our brain, which is it not received to our brain. Okay, because the thing is that there are some kind of threshold is there in for every neuron which is connected to the other neuron. Okay, so that might be thing that we are hearing something, but we cannot talk something, or because that signal is not received at the brain end, because there is something threshold. Okay, if that threshold is exited, then only the neuron will be fired, right? And if one neuron will be fired, which fires the another neuron associated with that, and the chain will be for so and so forth, that will be fired. Okay, and then our brain will be processed, right? So this is the fundamental for the human. Okay, so now if you'll talk about the activation function, the same activation function the scientists come up with, right? That is nothing but uh, the uh, the activation function. So there are different types of activation functions are there. So in the activation function that use for to bring the non-linearity into the model, that's the reason we are good to go with the activation function. So there are different kinds of activation functions are there. Okay, so can anyone tell me what different kinds of activation functions we are using in the deep learning? Yes, anyone like to add? Anyone like to add something?
Sigmoid function, sigmoid.
Yes, sir. Sir, having very good knowledge about the deep learning, I'm really glad for this. Yes,
No,
we do
no.
have yeah,
The
sigmoid. Then
sigmoid function also there are an ReLU rectified unit, linear rectified
ReLU.
unit.
Very good, sir. Apart from this, yeah, we do have sigmoid. We do have the
Hyperbolic function.
ReLU, sigmoid.
Hyperbolic function, tan
Yeah,
hyperbolic.
tan hyperbolic is also there, right? So these are some activation function, right, which brings the non-linearity into your model, and they are used in the neural networks. Okay, we'll discuss that during the hands-on how we can use it, so that So I'll talk about ReLU first, because the ReLU, which is very useful for the the CNN as well. We can use that in the different neural networks as well. So ReLU, let's suppose we are going to give any input to the ReLU. Okay, let's suppose this input is negative, then that negative will be value will be squeezed, and we are getting the zero output. Okay, so there will be no any output. Let's suppose we have all negative values -100, then we do have -90. For all this value, we'll get the output as a zero only. But let's suppose we do have 100 value, right? Then that value will be considered for the next thing, right? So that is the thing, right? That's the reason the activation function plays a big role in the artificial neuron. Yes. I hope I'm clear to all of you. Yeah. Now these are the component, and this components, and this is nothing but the perceptron, we can say. So there are multiple perceptrons there, right? We do have the single layer perceptron. We do have the multiple layer perceptron. There are multiple things. Okay. So let's discuss about each and everything in detail. How we can do these things. So I have one neuron here. You can see on the screen. So there is some animation is there. You can see. Let's discuss about this in detail how we can do this. Yeah. So yeah. So we do have x1. This 0.7 is nothing but the w1. 0.6 is nothing but the w2, and 1.4 is not w3. So all these are getting summation. Then the bias function is added, activation function to the pass. So as you, can anyone tell me? Here we have used one activation function. In the image, you can see, right? What is this activation function is all about? What is the name of this activation function? Yes, anyone?
Sigmoid.
This sigmoid. Wonderful, sir. Thank you. So, no, that will give you the probability from 0 to 1. We cannot go beyond that, right? So that is the thing, right? So that's the reason you can see we do have all these things. So we are calculating those things and we are passing that to the next thing. If that value is not up to the mark as per the actual values, that will calculate the error, and that error will be the travel back. Okay, so this is the representation of the DNA, as you can see, right? This is the input layer. Then we do have the hidden layer in between and the output layer that we have, right? So all these neurons are connected to each other, right? This is the neural network. That's the reason this learning call it as the deep learning, because we do have the different complex of the model over here, right? So yeah, so these are the neurons that we have with us, which will calculate all the complexity, and if this neuron will be fired, that will be same the same equation to the other neurons, like that only it will fire and will get the output, right? So let's discuss that with a very good visual, as you can see how this NN are working. Okay, so yes, see, now if you see here, we do have a neural network backpropagation. This is the backpropagation and the forward propagation. So let's discuss that in detail how it works. Yeah, see, we do have input layer x1, then hidden layers n1, n2, right? And we do have the output layer. So let's focus on how this works. So this cycle is broadly classified into two categories. One is the forward pass, another one is the backward pass. Okay. So in the forward pass, how it works? Let's see. So x1, these are the input layers. Then that will be hit, and it will pass through all the projected values. If there is any loss, that loss will be back propagated, and again the weights associated are getting updated, right? How this works? So forward pass. Here, as you can see, the neurons are firing. We are getting the output. If that is not up to the mark, right, that will calculate the loss, and again that will be back propagate. So this cycle going on, right, until will not reach at the point which is the global minima. Okay, so that is the thing about this thing, the forward pass and the backward pass. So this backward pass is depends upon one algorithm called it as the gradient descent, right? So they are using the gradient descent at the back end to do all this processing. So can anyone tell me one forward pass and one backward pass? We call it as the, what is the name of the terminology? Yes, anyone? One forward pass and one backward pass. What is the terminology we are using for that particular thing?
Feedback.
Feedback. Okay. Apart from this, anyone like to add something? Where our entire data set are going to pass to the the network. Anyone? Sir, would like to add something? Epochs, right, right. So yes, thank you, sir, for adding these things, right? Ishwar, sir. Epoch is there, right? As we are know, this is the epoch, right? So epochs are very, very interesting, right? Our training accuracy, our different things like what kind of accuracy should we have, and everything depend upon these things only. Okay, epoch, let's suppose we are running one epoch and we are not getting the good accuracy, we have to increase the epoch, right? Then we'll get the good accuracy. Again, there is something called early stopping and many more things are there. We'll discuss those things later. Okay, don't worry about this. Yeah, thank you, sir. Thank you, ma'am, for adding these things to me, right? Yeah, so now let's discuss how we can use this, right? How this backpropagation works, right? So this backpropagation works on something called gradient descent. Okay, so gradient descent, let's discuss about in detail how it works and what is the use of these things. Yeah. See, now this is the loss function. As you can see, we do have the curves, as you can see on the front, this is the cost function, we can say, our entire data set error, what we have. So this plot, plot it over, the loss, and on the x-axis, we do have the weights, right? So in this way, this works. Let's discuss how it works again. So let me just, go back and see. Now let's suppose we are going to start this thing here. Let's suppose we have started to initialize the weight from any random place, okay, and that will be go beyond, right? So as you are know, whenever we do have, let's suppose our point is here, local minima is here, we are going to draw one line, okay, and by drawing that line depends upon the slope, right? How the slope is it, okay? So let's suppose we do have the negative slope and we do have the positive slope, right? So that depend upon that thing, right? So as you are also might be aware about these things, we do have something called slope, right? So if you know, W old equal to W W new equal to W old minus dab of the cost function. Okay, so this minus function plays a very important role here to get the navigation. Okay, see, let's suppose we do have, this is the curve. Okay, this is the cost function, we can say, and x-axis we do have the weights are here, right? And on x-axis we do have the error rate, or can say the cost or the things. Okay, so what we are going to do, we are going to calculate the tangent for any particular curve. If that tangent here, we do have tangent, right? That is the negative slope or the positive slope. Depend upon that, we'll consider the direction, right? Let's suppose I do have line like this. It's a positive slope. Suppose I have line like this, then this is the negative slope, right? So likewise, it's depend upon those things, those parameters. So can anyone tell me what is our intention for any error, right? So we do have 3 points. Let's suppose here we do have 1 point, here we do have second point, and here we have third point. So where should our point should move, right? So shall we go to the first point, or shall we go for the second, or shall we go for the third? What should be our intention here? Can anyone tell me?
We have to
Yes,
find
fine.
out the global minimum, because we have to, in the every iteration, we cannot overshoot the global minimum. That is the
Right.
main objective of the gradient descent.
Yes, yes. Wonderful, sir. Thank you for adding these things, right? That's really correct mention by the sir, right? We have to reach at the point 3 is there. What will happen if we'll use the thing? Let's suppose we are at reach at the local minima, right? So if we'll draw one line over here, okay. So can anyone tell me what is the derivative of the horizontal line? 0. Yes, yes. Right? 0. Thank you, Ishwar sir. And if we calculate the derivative for the constant term, that makes 0, and our learning gets stopped. Okay. That's the reason the gradient descent is not used as optimizer. Okay. Whenever we are going to do for the linear, the deep learning models, right? So that's the thing, right? We need to reach at this point, which is the, the global minima. And that is something done, taken care by the Adam, right? That's the reason Adam comes into the picture. Okay, so that's the reason we should know this terminology whenever we are going to train the students, right? Or whenever we are taking any other FDPs. So that's the reason this themes are very important. Okay, so that's the reason I touch this point. Now let's focus on the upcoming things. Yeah. So how the gradient descent work, right? Now, we have discussed about the gradient descent, how it works, right? So I want to, integrate two things, the ANN and the CNN together. Okay, so we can just do that. We can discuss with the hands-on practice how we can do these things. Yeah. So now we have discussed about few parts of the ANN. Okay, how it works. Now let's discuss about the very interesting thing and very interesting fundamental to build any model, right? So let's suppose we do have the different data with us. Okay. Let's suppose we have the images and the text. So for images, whenever we do have images, we can build the model, which is something called CNNs are coming to the picture. Okay. And we have the textual data, we can good to go with the RNNs or the LSTM architecture. So this is, the basic, I think everyone is aware about these things. So now let's discuss how we can use the CNN, right? So CNN, convolutional neural network. Why come this terminology come into the picture? We are going to discuss these things in detail. Okay. So can anyone tell me why we are using CNN or the convolutional neural network? Yes. Question to everyone. Why we are using CNN for the images? What will happen if I'll directly use the CNN over the deep neural network?
Using complex network gives good result.
Okay, great. Apart from this, anyone like to add something? For a huge data set, it is indeed needed. Okay. Thank you, Ishwar sir. But may I know why it is required to have this CNN to deal with the complex data like the images or the video? Yeah, thank you, Sita ma'am. Apart from this, anyone? Okay, so let's do one thing, right? I'm going to use the paint to draw something. So just let me know if I can. So are you just confirm me? Is my paint is visible to all of you? Yes or no? Okay. So,
Yes, visible.
yeah. Okay. So I'm drawing something. Let's see why the CNN is very important. Okay, with a very simple example, the very basic example. Okay, I'm not going to make it very complex. Okay, let's suppose I'm drawing something, and you should know right what I'm drawing. Okay, so to identify any object, we don't look at the image, whole image, right? If we have a few features, that's fine. So I'm drawing something and you have to recognize what object or what thing I'm going to draw. Okay, so I'm drawing something, so bear with me for my drawing, right? Might be it's something different. Okay, yeah. Okay, I'm drawing something, just can just think what might be. Okay, yes. So can anyone tell me what is this? Just by looking at the image. Yeah. Is it visible, everyone?
It's elephant.
Elephant, right? Wonderful. See, now to draw this image, right, I have used only the edges, right? And I have not draw a full picture of the elephant. I just draw few points, right? Few objects, shape. We do have the tail as well, right? But I have not put the color. I have not put at the eyes. But still, you're able to predict these things, right? This is an amazing thing you can see, right? So to predict something, that means we are getting one insight. We don't have to focus on the other things, right? So to reduce down these things, right, we do have the CNN. Okay, so CNN do the same thing. Okay, we do have images that will be extract very needful things from out of all the images, and then it will be very easy for do the processing, right? Because if you reduce down these things, right, the memory will be reduced. Okay, if the memory will be reduced, the processing will be more faster. Okay, so that's the reason we can come up with the very good solution that is nothing but this the CNN. Okay, that's the reason this CNN come into the picture. Yeah. Hope I'm clear to this. What is the need of the CNN for the classification, right? So we have to reduce down the features. That's the reason we are good to go with this. Okay, so let me just start this thing again. Yeah. So see, let's discuss how it works, right? So for the human brain, we do have something edges, right? The visual cords are there that is connected to the our brain, and there is to detect the building, right? We should know the vertical lines and the horizontal lines. The building, what is the building? Building is nothing but the construction of the vertical lines and the horizontal line. And based on that, our brain is to having the capability to recognize it as a building, right? So there are different layers all together. And if we put all these things all together, then we can see the many things, right? So we have the receptives, in our brain, right? The different layer, LG and IT, V4, V2, V1. These are the edges that we have, and in this manner, our brains recognize everything. So if you know, right, our brain consists of many parts, right? So if you will see the back part, right, which is used for the to detect the images or the scene that we are watching through our eyes, which will be reflect on the back part, right? So that is the thing. See, now coming to this point, right? See, if you having the different features, first our brain will analyze the visual field, right? The edges and the line, then uh, the combination of that becomes the shape, right? Then we'll combine those things, it gets object, and the last but not least, we'll get the features, right? So based on this, our brain is working. Similarly, this analogy used by the scientist to come up with the very good solution, that is nothing but the CNN, right? So they have used the same thing. They have not, you know, used all the connections. They have just used the local connections. So they have reduced some connections so that to identify any object, we don't have want all the connections. Okay, so they have reduced down the connections, as you can see in the image as well. So they have added some layering, right? So we do have one layer to detect, the nose, then to detect the eyes we do have the different layer. So to detect the overall picture we do have third layer, right? So similarly, this is something hierarchical feature learning, that is something taken in by these images. And the last, we do have this special invariance. So that is nothing but the transformation of the objects, you can say, right? So let's suppose we do have an image. So for us, image, if you see it's vertical, okay, it's same. But for the computer, if you make it horizontal, that is something different, because the all pixels are get transformed to the vertical to the horizontal. Okay, so that's the reason. If you see, we do have different kind of features which we have, you can see on the screen as well. So we do have vertical image, horizontal image, then the shear image as well, right? So this whole coming, the package, we can say it's nothing but the CNN. Okay, so let's discuss this, how we can come up with this. Let's with a very good example on the screen. Okay, yeah. So now if you see here, we do have the images of the birds, right? So if you see image of the bird, right, and I want to detect the brick of the that bird, right? If you will see, if you focus on the brick, right, this is the image of the brick that we have, and we are going to pass these things to the the neuron, and we'll get the output, right? And if this output will be detect that this is a brick, right? So for this, we should have the brick filter. Okay, if we do have the brick filter, then that will be identify it as that is a brick, right? So let's discuss how we can do these things with a very good example. Let's suppose I have the input images. Okay, see, now I already told you image is nothing but the matrix that we have. Okay, input matrix, this is for one image, I can see, right? And for this image, we are going to use the multiple things, right? So let me just use this pen. So we do have, this is image, and this image will be consist of the height and the weight and channels as well. Okay, let's suppose this is a grayscale image, we do have one channel only, and we do have one feature, right? This filter, so that filter will be straight over this image and we'll get the output. Okay, so this input image we have the filter to revolve around it, and that will be give one output. So we are going to discuss this, how this works. Okay, so if you see this convolution neural network, which consists of the convolution word. Okay, so that convolution word comes from the word called the convol. Okay, so convol, the meaning is of the convol in the mathematical terms as the multiplication. If you are aware about these things, okay. If you are not, it's fine. Okay. So the convol operation we are going to do right now. How we can do that? Let's see how we can do these things with a very good illustration. I can see. See, now I have one image with me. This is image. Let's take the another pane so that it will be indicated for all of us. So this is input image which I have. I already shown you what image is all about. It's a pixel. We do have 0, 0, 75, 80, These are the pixel values, whatever we have. And this is a filter which will be stride over these images, okay, and it will stride and that will give one value, okay, which is map. Okay, so this is input image, this is the kernel, we can say, or the filter, and we are getting the output, and that output is nothing but the feature map. Okay, that feature map is very, very important to understand these things, because whatever we are doing, right, this depends upon the output shape of this, right? So in this way this work, let's suppose I'm going to just do it again once, just a moment. Let's see how it works. See, now if you see, the filter is tried over the images and we are getting some values at the feature map. So these values are nothing but the multiplication. As I mentioned, the convol is nothing but the multiplication, right? So if you see, we do have the matrix. I have mapped that here. Here we do have matrix. This is the filter which I have applied. This is the 0 value, which is here, 0, 75. 75 is here, right? And 0, 0, 0, the back numbers are nothing but the image numbers, and the front, which are in the blue color, which are nothing but the filter values. Okay, and if you do the multiplication, as I mentioned, the convolution, the convol is nothing but the multiplication, so we are going to do multiplication at the back end, right? So 0 into -1 gives me 0, then 0 into -2 gives me 0, 75 into -1 gives me 75. Just like that, I'm going to find out the summation of this, and I'm getting the 150 number, right? Like that. So this, in this way, we are getting these things. Okay, so similarly, the filter will move straight over the another pixel, right, like this. So 0, again I'm going to do the same thing, and that will be cover a whole picture, right, a whole picture, and I'm getting the feature value, right? So in this way, I'm getting the feature map. Okay, and what I'm doing further on this feature map, let's discuss, right? So we are going to do subsampling, right? We can say it's a pooling. Okay, so there are different poolings are there. I'm going to pull out important features out of the feature maps, right? Let's suppose I'm going to use the max function for this. We can use the meaning as well. Mean depend upon the the data set and whatever we are using, the domain knowledge and everything is depends. We'll go with the mix mean or the max. Okay, yeah. So now let's focus how we can use this, right? Let's suppose I have the feature map, have used a max function over here, as you can see, and that max function will extract very important features. I'm getting 5 over here, because if you see, if you look at this first quartile, right, so we do have -18, -20, -23, -12, -11, -7, and 0, 3, 5. Okay, out of that I'm able to map these things on the matrix, which is a 5 is a maximum value, right? 6 is a maximum value, and the 17 and 16 are the maximum value. So that means I have extracted the important features from this output map, right? So that's the reason the convolution neural networks are very, very essential, right? So I have drawn one elephant, right? I have drawn only, I have subsampled that thing to the edges only, right? That's the reason I'm able to retain the important features, right? So that's the reason this pooling is very, very important. So this is the layer, right? Second layer. The next we do have in the CNN different layers. Okay, it's not stop until the one layer, two layer. It's depend upon the multiple layer architecture. So we do have BGG16, we do have BGG19, we have mobile net. So these are the pre-trained models used by the people to come up with a transfer learning approach. But now we can just discuss about the mechanism behind how the CNN works. Okay, so this is nothing but the architecture of the CNN. Okay, we can add multiple layers. So we do have the convolution layer, then we do have max pooling, convolution followed by the max pooling. Okay, so we can do these things. So let's discuss. Okay, now coming to the point, right? Let's suppose I do have all layers with me. I have extracted the important features. Okay, so imagine a situation as we all are aware about these things, right? In class, we do have the students, right? And I ask all students to just go from the class. Okay, you have to do the exit from the class, and door which I have, which is very smaller one. Okay, where one person can take exit Okay. So is it possible for all students to go at a time from the class? Is it possible? Can anyone acknowledge me? Is it possible all time? Yes, anyone? No, no, right. I'm really glad that everyone is listening to me and responding, right? So that's the reason, right? What we can see, one person, one by one student will go one by one, okay? And then it will be very easy to to having the queue, and everyone will be get out of the class. Okay, that is the very the logical thing, right? So same thing we are doing here, right? We do have the matrix over here, 5 6 17 16. So now I'm going to flatten that thing, right? Only one dimension is there, right? So that's what I want, right? So that's the reason this term come into the picture, which is called the flatten layer, right? Yeah. So see, flatten layer, how it works. Yeah. So if you see, I'm going to convert all my matrix into the one dimension. And now on the top of this, what will happen, right? We are going to add the NN. Okay. So CNN, which will bring only the important feature, it will retain only the information feature. And then if you see, if we'll uh, apply the NN, okay, then we can use the NN now, because we do have very less pixels value with us, and with the help of that we can now predict the things, right, in very simple manner. So this is the idea behind using these things. So these are the things that we have discussed, right? How we can come up with the CNN. Okay, let's discuss about these things into the hands-on practice as well. Don't worry. Okay. Yeah. So we do have applications. Let's discuss about that. In manufacturing, we can use it. We can use it in the transport, healthcare, the banking, e-commerce, right? Whenever we have the images, right, we can use it, right? So in manufacturing, let's suppose I'm working in, let's suppose I'm working in the mechanical field, and we do have the conveyors, and we do have, we do have the metals, and they're having the cracks in between that. If I'm able to have the images of the cracks, right, I'm able to prevent those things earlier, okay, before the manufacturing. So that we can do with the help of the CNN. Okay. So now let's focus on the hands-on practice that will be help for you to understand these things in detail, how these things work. So I'm going to take one very basic example, okay, which I have with me to understand these things. Advanced, we can use multiple things, but to discuss these things, I'll go with the only very basic thing, because I'm going to use the Colab. So let me just open that. Yeah. So before that, yeah, thank you everyone for giving those such a nice feedback and listening me to for 1.5 hours, because this is very difficult task to all of us, right? To listen everyone, right? This is very difficult task, but still you're listening to me. That's really nice for me. Yeah, thank you everyone. Yeah. Yeah. Now, let's discuss about the hands-on practice, right? How we can do that. We have just theoretically discussed how we can use a CNN, but now let's discuss, right, how we can use it in the real practice, so that no, we can discuss this with the students, and that will be very engaging session for all of us. Okay, so that's the reason I think that I have to go with the hands-on practice. Yeah. So you can also practice, you can also try from your end as well, right? It's very simple thing. If you want, I'll share the notebook link with you. You can just later see the things. Yeah. Thank you, ma'am. Right. Yeah. Now, if you know, Google Colab is a very useful notebook, I can say, or the platform by which we can use it. Why I'm using the Google Colab? Because it having some very virtual processing unit and the very good power. Okay, if you click here, if anyone wants to change the runtime, we can do that. We do have the multiple runtimes. I'm going to change those runtime. So on the right hand side, we do have change runtime option. So if you are building the model, I'm recommending all participants to use this GPU, okay, because the CNN models and the NN models are a bit difficult for the calculation. If we'll do on the CPU to build one simple model, you should, it will take one day, right? If you use the GPU, it will take it will complete within the 5 to 10 minutes. Okay, so that's the reason I'm requesting all participants to use the GPUs if you want, right? If you want, I can share the notebook with you. Don't worry. Towards the end, I'll share these things with you. So now there is some update in the Google Colab. If you check from your end as well, if you click on the Data Explorer, we do have the data set available already. So I have used the Kaggle Hub here. Okay, so I have used the FER 2013. You can also use that. I'll just let you know how we can do it from the scratch. Okay, so FER is there, right? Just click on this. And I had just copied this code from here. Import Kaggle Hub path. So I'm going to create one object path and I'm going to insert the dataset there only. Okay, so I'm going to run the first thing. So I got the dataset from there only. Okay, so this dataset is all about the emotions of the people. So we do have the different emotions, right? Sometimes we are getting angry, sometimes we get surprised, right? Sometimes we are getting sad, right? So we are making different faces. Even our child, right? They, if you look at their faces, they are differently, they are making very different faces, right? Sometimes get very angry like that only. Okay, sometimes they are very happy, they are very joyful whenever they got something, right? So we can use this thing. So let me think of the problem statement, how we can come up with a very good problem statement. Because in any project, the first step is to define the problem statement. Without problem statement, we cannot come with any project, right? So this is the first approach. So let me figure one problem statement out of this data set, right? The problem is that, right, based on the customer's expression.
Hello.
Yes, hello. Yes, anyone want to add something?
Okay, ma'am. Nice, ma'am. Nice. Thank you, ma'am.
Yeah. Thank you, sir. So now, if you see, right, if you see, right, in the if you see, we do have one business problem with us. Okay, so what is the problem? Let's suppose I'm in a shop. I having the jewelry shop with me, and I have put one camera inside the shop, and based on the user's experience, we can see, right, whether that particular customer will buy this gold or not. Or not about only gold, I'm just giving the example, we can take any example. And let's suppose they're getting surprised, and there are different things we can come up with that. So based on that expressions, we can come up with that the particular customer will purchase that product or not. Okay, so we can come up with that solution for this. Okay, so first of all, we should know how the camera will capture the emotions of the people, right? Then we can come up with that solution, right? So now we are going to learn, we are going to build one model. That model will capable of identify the human faces, and based on the human expression, we can decide, right, whether we are going to do or not, right? There are multiple things here. So now let's do that. So I'm going to import the OS to just let's check the path where this object is stored. Okay, so this is the thing. So my object is stored in the Kaggle input fair test and train. So we do have two things. I'm going to add that path to my directory. Okay, so I'm going to make the object. I just want to check. So for this, I'm going to use the TensorFlow as the TF, right? Okay, so I'm going to import some imported packages from here. So TensorFlow.keras processing image. We are going to import the image data generator for the data augmentation, and we are going to use the matplotlib to visualize the image. Okay, so I'm going to run this cell. Now I have just checked, right? So image size which I have with me for this data set having 40 by 48, right? And the batch size 32. We have decided, right, these things. Let's run this. So now this data generator will rescale my images as someone mentioned, right? Sir is there, right? They mentioned that we can do the normalization. So the rescaling is the normalization that we are going to do. That means we are the normalization is nothing but the normal. Normal means in the statistics, normal curve we have bell-shaped curve. So which having the zero mean and the standard deviation which we have, right? One as a standard deviation. We are going to convert all the pixels value. We are ensuring that should be in between 0 to 1. Okay, so that's the reason I'm going to run this. Now here this line is for train data generated dot flow from directory. Okay, so I'm going to just classify the things, right? I'm going to give the directory. so that I can understand how many images which I have and how many classes that we have, right? Let's do that. So I have color mode as the grayscale, okay, and the batch size, which is the 32. The class mode is the categorical. Okay, why categorical? Because we are doing the classification. Okay, so that's the reason I'm going to do that. Yeah. So if you check, we do have the images, right? How many images do we have? So we have 28,709 images belonging to the 7 classes. Okay, 7 classes which are nothing but the 7 emotions of the person. Okay, I'm doing the same thing with the test data generation. I'm going to do the rescaling. I'm going to give the directory for this. So in the test, we do have 7,178 images belonging to the 7 classes. Okay. So this is the thing, right? Which we can have. Okay. So in the test, we do have 7,000 and in the training, we do have 28. Okay. So can anyone tell me, is it okay? Should we have high uh, high size of images in the training or in the testing? Yes, anyone? Data sheet. Okay, this data sheet. I'll just share the whole notebook with you. Don't worry. Just a moment.
Training data set should be larger than your testing data set.
Yeah, wonderful. Very good, right? Because whenever we are training to the students as well, right? We are giving more training to the students and student will perform the practicals and everything. They are giving the examination and everything. So for training requires more time, right? That's the reason. I'm going to share these things with you. You can try from your end as well. Okay. I'm giving access to you. Just a moment. You can run directly. This is the ready to run. You don't have to do anything. Just run the cell. That will be helpful for you. I'm going to share that with you. Okay, just let me know. Is it accessible for all of you or not? If not, I'll just change the things. Yeah. So now let's discuss in the data generation. We do have the test and training, and obviously we require a good number of images in the training as compared to the test, right? Yeah. So now let's see what are the class indices that we have to. So for that we have the method, right? We can say the attribute. So angry, we are assigned to 0, disgust 1, fear, happy, neutral, sad, surprise. So we do have 7 classes over here. Okay. So let's visualize the images. So visualize image. I do have this code, right? So if you know matplotlib, we do have this for loop, and we are going to use the subplot to plot the sample images from the strings. Okay. So now if you see, there are few things: surprise, fear, neutral, happy. Okay. Then happy. Right. There are different. We do have surprise, fear. Someone is fearing, right? So someone is very happy. Surprise again. So these are the samples that we have. Okay. So these are in the grayscale images. Okay. So this is the thing, and the image of the size is the size of the image is 48 by 48. Okay, that's the reason we have passed here. Then let's suppose I'm going to build the very basic model for the discussion, right? So I do have the one model. Okay, so from TensorFlow.keras, we are going to use the sequential model. Okay, so can anyone tell me what is the use of the sequential? Why we are using the sequential as per the name as well? Yes. Anyone? Why we are using the sequential here? So let me tell you in detail, right? Sequential, which will combine all the layers all together, and from left to right, it will do the yeah, we can use it for the videos as well, but in this CNN, we are using this for only the conventional neural network. So to combine all layers, okay. Thank you, Sunil sir, for adding more clarity on this. So combine all the layers all together, and that will be processed sequentially, okay, as the name suggests. Then we do have the layers, the con2D. then max pooling 2D, and the flatten and the dense. Okay, so these are these some important library that we have imported to build our model. Okay, so model equal to sequential we have used. So I'm going to pass first layer, the convolution layer. Okay, as we have discussed in the PPTs as well. Okay, let me just go back so that I can relate those things with you. See, now we do have convolution layer with us. So this is the image of, and this is this size of the images, and this is the filter that we have. Okay, so if I'll relate that thing here, con 2D. Sure, I'll share the PPT with you. Don't worry. Okay. So con 2D, we do have 32 images, 32 filter size. So this 32 is nothing but the number of neurons, or we can say the filters. Okay. So I'm going to pass 32 filters for this, so that it will be, capture the information. Okay. And then we are using the activation function as the ReLU. We have already discussed these things. Activation function ReLU, rectilinear unit, which will ensure that we don't have the negative values. Okay, so that negative values will be to create impact, right? That's the reason we are going to split that. Yeah. Then input shape 48 comma 1. So can anyone tell me why we are using 1 over here? Anyone? In the input shape we do have 48. We can understand 48 is nothing but the height. The 48 is nothing but the width. What is this one? Anyone? Depth, true value. Apart from this, anyone? Depth. Sampada, I'm saying depth. Okay. And let's suppose I'm using 2 over here. So what will be changes will be there?
I think the depth.
Depth. Okay. So let me add some idea, right? Let's as you can see, we have used the grayscale images, right? Yeah, number of colors. Okay. Thank you, Palak ma'am, for adding the information. Okay. So this, as we're using the grayscale images, that grayscale images are nothing but one, we are considering it as a channel. Okay, as per the norms. Okay, and if we have color images, we can use 3 over here. Okay, so that one change we have to make if we are using the color images, right? Yeah, so just make those things in your mind. And to pass any image, this is the format. Yes, 3 for the RGB, right? Wonderful. Okay, so this is the input image that we have.
If you
And there
mention
is
one
some,
means you can use only one color, ma'am. Sir?
yeah, pardon, sir.
If you're using one means it shows only one color.
Yeah, only one channel I can say other than the color. Okay, so we do have different images, right? We do have, RGB images, red, blue, and
Okay, if you mention 3 means it shows for RGB, red, blue,
RGB,
green.
right? Correct,
Okay,
correct.
thank you,
Yeah,
thank you.
yeah. Okay, so now if you see here, we do have con 2D over here. 3 by 3 is nothing but the size of the filter that we're going to add. Okay, and the max pooling, as we have discussed, right? Max pooling. What is the max pooling is all about? Just get some input, they extract the meaningful insight max function. Okay, so max pooling I have used. Then again we can add another layer, which is the 64 neurons, we can say, or the number of filters, and the size is 3 by 3. Okay, and the max pooling 2 by 2, like that. Again, I'm going to flatten that, as we have discussed, right? We have used the flatten, just to ensure that all vectors should be in the one dimension, so that I can apply the ANN. So this is nothing but the ANN, and the above part is nothing but the CNN. Okay, what happen if we'll use directly ANN? Okay, that model will be more complex because we do have multiple features, and due to that the time will be more, right? So to reduce that, we have used the CNN. So this is nothing but we can say the ANN, and that's 188, 128. Again, we do have the neurons, and this is the ReLU function, and then 7 is there, right? So can
you
anyone tell
discuss the
me?
purpose of the dense?
Dense is nothing but the layer which is used, okay, as we have discussed, right? In the deep neural network, we are adding the layers, right? We do have layers. So to add this layers, we can add multiple hidden layers. Okay, we can say. So if we have multiple hidden layers, then that will be calculate the more number of features. And once we have done that, right, we are getting the calculations, and we can we can solve the problem with the XOR as well. Okay, so that's the reason we are using the different layers, hidden layers, or we can say the fully connected layers. Okay, I hope I answered your question. Yeah, I think yes. So now, can anyone tell me why we are using this 7 over here? What is the purpose? Why we are using 7?
Filter value.
Not filter as such. 7 classes. Thank you, Rajesh sir, for adding the point, right? 7 is nothing but the classes. As I mentioned earlier, right? We do have the different classes with us, right? So this happy, neutral, right? So these are nothing but the classes. Let's suppose I'm working on a different data set, which the portrait data set are having the 3 classes: the early blight, late blight, and the healthy one. Yeah, I'll having the 3. Then I'll use 3 over there. I having angry, disgust, and the feature, the fear, then the happy. These are the emotions, right? So depends upon the the class. How many classes do we have? We'll change the value over here. So this is nothing but the output layer. Okay. So this is my input layer. I have added the convolution layers top of that, and this is the hidden layer, I can say, and this is nothing but the output layer. Okay, so this is the structure of the any model for the deep neural network. So I'm using the software function as the uh, activation function, because I'm using here the multi-class classification. Okay, so can anyone tell me, let's suppose I'm using the binary classification. Okay, which activation function should I go for? Anyone? Tanish, yeah, Sampada ma'am saying correctly. Okay, we'll go with the sigmoid. Okay, because we are doing the binary, right? So we can go with that only. So for the multi-class classification, we are good to go with the softmax. Okay, so this is the art. We can add multiple layers. That is not the rule, right? But for the sake of simplicity, I'm just giving these things. So we have come up with the the architecture. We have built that. Let's see the summary. Okay, so to get the summary, we can use the model.summary. Okay, so here we do have the multiple layers, as you can see, and these are the
Sorry for
parameters, right?
interrupting, sir.
Yeah.
Sir, softmax, you said multi-class, right? For multi-class classification.
Right, yes.
Sir, is there any other function, sir, for multi-class? What are all the activation?
Generally, we are good to go with the softmax only, okay, for
Okay,
this.
sir.
But if we do have the binary, we are good to go with the sigmoid.
Sigmoid, okay.
But I need to explore more if there is something, right? But as per my knowledge, we are using the softmax only to get the probabilistic things, right? So
Thank
that
you, sir.
gives me the probability
Thank you,
0.1,
thank you,
0.8.
thank you.
Okay, fine. Yeah. Okay, so now let's discuss about the layers, how we are getting these layers, what is the thing. So this is very important thing. Okay. So shapes are very important. Okay, and the parameters are really important. Okay, because this trains parameter gives me the model. Model is nothing but what? We are saving that model as for the machine learning. We are using the pickle model.pickle. For the deep learning, yes. Anyone want to add something or ask something?
Ma'am, I think it's 9 o'clock now, FTP.
I thought that we do have session until 9:30, but I'll just wrap up that within the 5 minutes. Okay, fine. Just let me just run this quickly. Just let me do that so that let's change. So I have done this thing. So if you see, we have total parameters. These are the weights we can say, and we have calculated that. So these weights are nothing but the models, right? Which is used. The compile, we do have optimizer Adam, as we have discussed. Can we use the squeeze activation function? Yes, we can. We can do that. But for most of the times, we are good to go with the softmax only. Yeah. Yeah. Then loss. Loss is there. Let's suppose I'm using the binary. Okay. Sure, definitely. So loss, let's suppose we are using the binary class classification. So can anyone tell me what loss will go for? Here we are using categorical cross entropy. Let's suppose I am using the sparse. Okay, apart from this, for binary, we are using the binary cross entropy. Okay, for the multi-class classification, we are good to go with the categorical cross entropy. Okay, we can use the sparks as well. Okay, that's not the case. Okay, then matrix as the accuracy. Okay, so this is the thing. So we are going to run the epoch. We are going to train the model. Okay, on the train and validation. Yeah. So let's wait for this. Let's wait how much time it will take. So that will build our model to do the prediction. Okay, this is the thing. So that's all for this. I guess we have covered many more things. Once we have done that, we can do the prediction. Okay, for the different use cases. So this is the thing for the CNN. If anyone wants to ask something, you can just go for that. Meanwhile, you can take the any doubts.
Sir, can you share the PPT for us?
Yeah, sure, sure. I think right, you like the PPT. That's the reason everyone is
Yes,
asking for the PPT.
it's very informative.
Yeah,
We
sure,
can
sure. I'll
use it
do
for.
that.
Thank you, sir.
Yeah, I'll show that. Don't worry.
Sir, can you please explain some detail about transformer?
Thank you very much.
Sure, sure. Definitely, I'll go to discuss the transformer as well. Yeah. Thank you, everyone. I'm really glad that you like this session. Okay. Definitely, I'm going to talk about that in
Thank
between
you.
because. Okay, just a moment.
Thank you very much.
Yeah. Sure. Thank you. Welcome, everyone. Now, let me just talk about the transformers. I'm on the same point, right? We do have this
Nice.
RNN as well. So RNN we are going to use for the textual data, and we do have long short-term memory LSTM, which is again used for the textual data. Okay. Thank you, everyone. Thank you for your time. Yeah. So do we have? Let's talk about the transformer. Okay. Yeah. I'll talk a bit about the transformer. Okay, what is the transformer? It's all about, and also I'll talk about how we can do it recent, like what the people are using in the recent, right? They're using the ATOKeras nowadays. People are using ATOKeras to build the models. Okay, so now let's talk about these things. Why we are using the transformers? Okay, so introduction to the transformer architecture, deep learning models for the language task. As you know, right? We do have one image transformer and input images and output images. Okay, if we are passing any input to the transformer, we are getting the output. Okay, so the transformer, let's discuss in a very layman term what is the transformer is all about. Okay, so deep learning model for the language task, we are using the transformers. Okay, so process the entire text at once, unlike the RNNs. So what happened in the RNNs? RNNs are using very this approach where it is used for the translation. It will not generate the text. Okay, so uh, if you see any word, right? I like the Dhurandhar movie, right? So this is the word. Let's suppose this is the word which I have in this is a sentence. So Dhurandhar, that might be movie name or anything as such. Let's suppose take the another example to get the context of this. Okay, why we are using the transformer? What is the difference between the RNN and the transformer? Let's suppose I like apple. So this is my statement. So if you see that statement, apple, right? Apple might be the company or might be the fruit, right? And if I'll say I like the apple fruit, then that will make sense, right? So to get the context out of the RNN, right? We are good to go with the transformer because transformer is capable of understanding the context and giving the generate the output. Okay, that is the reason, right? We are good to go with the transformers. Okay, so now why not we are using this transformers? Because slow and memory limited. As we are know, if we'll do it for the long chain, the very big paragraph, the RNN will not work or the LSTM will show some of the problematic things. Okay, they're having the vanishing gradient problem and they're having the exploding gradient problem. That's the reason we are good to go with the transformers. Okay, so that's the reason the transformer come into the picture. Okay, so this in this the way how it works, let's discuss. Okay, in 10 minutes, then we can conclude the session. Yeah. So understanding the encoder in the transformers. So now what is meant by encoder? We are going to add the value or we are going to assign the value to the words, right? So that we can use that numbers for the processing, because we know that we cannot use the textual data, as the computer will not process the textual data. So we have to convert that to the numbers, right? If I convert this number cat to the one specific number, that will again not work, because there might be different cats as well, right? There is no any context in between that. Apple might be the company, might be the the fruit as well, but we should know the context, right? So everything is map those information in the vector. That information consists of all the aspects, right? It consists of the context of that, then the relation with the other words, right? There are many more things are associated with this vectors. That's the reason we are doing the embedding, right? And the encoder are using. Okay, so then we are using the position encoders. Okay, this transformers don't know words or order by order by default, so they're adding the position information to the embeddings and helps the model to understand the sequence. Okay, so let's suppose the position. Why position encoding is important? Because let's suppose I'm talking like I like this movie, and if I change the the sequence, the Durandar I like, right? So then that will not make any sense. So that we want the position encoding to put all the words order by order by grammatically it should be correct, right? So that is something taken care by the position encoding. Then we do have self attention mechanism. Okay, so there is one very famous public the research paper on this. Okay, if you see this, if you Google that, attention you need, right? This is very famous paper. If you want to understand this deeply, you just have to look into this. Okay, because it's adding many more points about the Gen AI, generative AI, which started from this things. Okay, yes. So this self attention mechanism focuses more on the relevant words. Okay, no relevant words. What is what it mean, right? We are saying the words are relevant. Like sat is Saturday, which is pay attention to the cat, and mat as well. Okay, so there are the relation in between these words. Okay, so that the weightage it's built within the self attention mechanism. Okay, so this is the thing. Then we do have fourth step, multi-head attention, right? So that doesn't mean that we are passing only one layer. Okay, as we have seen in the deep learning as well, we cannot do that with a single layer because it will create a problem, right? So to combine all the context or the summary, right, we should have the different things, multi-head attention. Now right now ChatGPT is also there, right? So ChatGPT can only generate the text. Previously, now the ChatGPT also can generate the images, right? So this is something which is handled by the multi-head attention. Okay, so the multiple attention layers run parallelly. Okay, each head focuses on the different patterns, and the combine it will understand everything and giving the context, right? So that context again added to the next step, which is the add the normalize. As we have discussed normalization, what is all about already, so I'm not going to this. So to prevent that, overcome the RNN exploding gradient and the vanishing gradient, we are good to go with this normalization. Yeah. Then we have the feed forward neural network. Okay, as we have discussed, right, how this works, feed forward, that x1 into w1 plus x2 into w2 like that. Okay, and last we do have the output of the encoder. Okay, so we are getting all the encoder output. Word representation are now context rich, having the context. If I'm saying I like the Apple company, that means it's talking about the Apple mobile phone or the company, right? Like that only. So this is how the transformers works. So that is nothing but that there are different transformers. There are something called large language models are in the market, right? The Gemini that we have, right? Then the Chat GPT. Okay, then we do have DALI for the images, right? There are multiple LLM models are there for the different purposes. For the images, we do have different. For the text, we do have different, right? Likewise. So LLMs are advanced models for the understanding and generating the human language. Okay, built using the transformers architecture, analyze the full text instead of the word by word. Okay, एक word को ना जाने हुए वो पूरा एक ही बार में paragraph पढ़ेगा और बताएगा. Sure, I'll provide the PPT. Don't worry about that. Okay, I'll give everything. Don't worry about this. Then why we are using the LLM? Why it is important? Because we want to perform the task, right? As we are using the GPT for to get, so GPT stands for generative pre-trained model, right? So generative pre-trained transformer. Okay, that's the reason the chat GPT consider it as the GPT. Okay, if you see that we have one model, right? We can use it for the image generation, voice generation, text generation. Many tasks can do. We can come up with the bot, right? Questioning bot, right? Which can ask the frequent questions. Then translation we can do, summation. Let's suppose I want to know the book summary. I'll go with that, right? Writing and the context generation we can do, code generation, right? So for everything we do have different things. Yeah, applications where we can use it. So we can use it for the content writing, like the blogs post, right? I want to post blogs on the LinkedIn, or I want to post the those on the social media. I can good to go with this, right? The Q&A, as we have discussed, right? Let's suppose the IBM is there, right? So they're having the bots with them. So they're not, there is no any person behind, sitting behind to write something or the chat something. Okay, there is something called, the bots are assigned for this. Okay, so if you say Watson is there, okay, Watson X is there to handle the queries, right? Suppose I'm writing, I have this query, this is something not working with me, and definitely that bot will be connecting with me, right? Let's suppose, can anyone tell me, if you are there, which bot is used by the railways? कौन सा bot होता है वहां पे use railways में? Anyone? If you know, you can just let me know. On the railway website, if you visit that website, we do have something called bot is there, right? What is the name of the bot? Anyone? Let me just check. Disha, okay. Thank you, ma'am, for adding this. Okay, it's put an energy in between me. It's like that, right? There is no any person behind, sitting behind and answering that thing. Okay, that is something called, the bots are there, which are capable to answer the questions based on the context which we have asked, right? So all database we have, and that bot having the databases, and if you are asking any questions, right, that will be answered by that bot, depends upon the context at what thing we are asking about, right? So that is something we can use KNA, right? Then text classification, we can use it for the sentiment analysis. Let's suppose I'm posting something on the LinkedIn, posting something on the Twitter, different tweets are there, right? So to get the context of the page, right, we cannot read all the things all together, right? So for that we have different bots, right? Even for the code generation, we can use the Copilot, then the Whisper, then the ChatGPT, right? There are multiple bots are there available, right? People in the industry are using the specific customized bot. Okay, so these are some applications we can use, right? Yeah. Thank you, sir, for giving me such a good feedback. So now let's go to the closure of this. We have learned about the basics of the deep learning with the hands-on practice, right? We have understand how the CNN works and what are the applications, and we have used the concept of the RNN. Okay, we have discussed, right, how we can use it, right? So yes, any questions? Over to you guys. I guess I have exited the limit, right? But if you have any question, you can ask me. Otherwise, no, I'll just go with the. Yeah, sure, definitely. All right. I'll just share my contact details with all of
Really,
you.
it's a very
Okay.
useful, wonderful session to us. Thank you, sir. Thank you so much.
Yeah. Thank you, everyone. Thank you, Kapil sir. Thank you, everyone. Okay, so I'll just go back to the Google Colab and the PPT. I'm going to share the PPT with you because everyone is asking for the same. Okay, so I'll do one thing. I'll just share this PPT with the ma'am. Okay, and then they will definitely
Very good, sir.
share
Very
it.
good.
Yeah.
So
Thank you,
please share
sir.
the
Great
part of
knowledge
that.
session you're sharing, sir. Great knowledge, sir.
Great. Very good, ma'am. Very good,
Great
sir. Very
session,
good.
sir. Very well coordinated, sir. Thank you.
Yeah, thank you. So yeah, see, now we can see, right? We do have the image right here. We have process that image and we are getting something, like, so this is the the basic idea, right? As we are using the very simple model, that's the reason we are getting very less accuracy, I can say. So the training accuracy is good, but testing, if you say, it's seems not good. So that's the reason we are not getting up to the mark results, but we can tune this model to get the better accuracy. Okay, so this is how the CNN works. Even now I can see, right, at the background we do have the image, right? So this is nothing but the CNN as well. Okay, this is the real-time application, you can say, right? So that's all from my end. If you have any question, you can just go ahead. Otherwise, we can wrap up this session. Yes, if you have a question, you can ask. Otherwise, I have done from my end. I'll share my PPTs. Don't worry. Sure.
If the presentation and the contents are good like you, right? So nobody worry about the time, it's exceed or not. So compliment from my side.
Yes, sir,
Yeah,
exactly. I'm talking about the same. There is no any question because you have explained all the things in very detail and in a beautiful way.
yeah.
Thank you
Uh,
so much, sir.
Thank you, ma'am.
Time is not constant, sir. You're
Uh,
nicely
Thank you very much, sir. Thank you.
Sir,
mhm.
the session offer a
Thank you.
clear, systematic introduction to fundamental of deep learning. Example and illustration share the during the session. Enable participant to appreciate the relevance with various applications like NLP, computer vision, and Gen AI. Thank you for sharing valuable knowledge for expertise which contribute to academic value and success of ATAL-FDP.
Sure.
Request
Thank you, sir.
to open the videos, please. For the photograph, please open on your videos, everyone. Audio. Next.
करना तो है नीचे ठीक है और बीपीएस और बाकी ओके